YouTube now. So, hello students, welcome to the class. Today we will be our day 18 of this JEE 40 days crash course, and we will begin with the chapter Chemical Kinetics. So, please join the class quickly. We will begin in few minutes. So far, we have covered chapters like electrochemistry, thermodynamics, thermochemistry, some basic concepts of chemistry, then solutions, and today we will be moving on a very important chapter which is chemical kinetics. Now, let me introduce first of all to its analysis. Here, it was seen that from 2017 to 2024, 10 questions were asked, and at least one question is always there on your JEE question paper from this chapter. And there is a weight percentage of 4.16. Now, talking about the important topics of the chapter. So, the most important topic would be related to the Arrhenius part. Okay. So, you can see maximum questions from this temperature dependency of rate of a reaction, and it is described by the Arrhenius equation. Now, second thing which is important in this chapter is your first order reaction and the order of a reaction. So, these are three important parts of the chapter. What are they? First of all, order of a reaction. Second thing, first order reaction rate law, and third thing is the temperature dependence. Now, temperature dependence questions are seen in 2023, 2021, okay, as well as in the year 2017. Today we will start with the rate law. We will study about the first order reaction, and in tomorrow's class we will learn about the temperature dependency. So, what are the topics that we are going to cover today? First of all, we will see what is rate of a reaction. Now, in thermodynamics, we studied that whether a given reaction is spontaneous or not. So, it basically means whether it will happen or not without any external factor. But in this chapter, which is chemical kinetics, we will study that at what rate your reaction will occur. What will be the speed of the reaction, how fast your product will be formed from your reactant. So, this is the basic part which is described by the chapter chemical kinetics. So, first of all, we will study that what is the rate of a reaction and how do we define it. Then after, we will move on to rate law and rate constant. Next, we will see what is order of reaction. Again, this is a part of rate law. Then after, we will move on to molecularity. And lastly, we will see the differential and integral form of your zero order reaction. Okay, so today we will see the differential and integral form of zero order reaction, and in this chapter you will need some knowledge from the differential calculus because there are some derivations and they are directly derived using your differentiation and integration, basically from the calculus part. Okay, so starting with the first thing, which is rate of reaction. In a simpler terms, if I define, it is basically the speed of a reaction with which the change of concentration of reactants or products is taking place with unit time. Now, consider a hypothetical reaction in which we are going from A to B. How do we define speed here? So, it can be defined in two ways. The first way is average rate of reaction. Now, this part is very, very important in every upcoming part, you will see the instantaneous rate of reaction rather than average rate of reaction, and it is discussed here only. Now, what does it mean? It means that your rate of reaction is being averaged over a large interval of time. Okay, I would say a greater interval of time as compared to the instantaneous rate of reaction. What will be the unit here? So on the numerator, you can clearly see that we have concentration term, and here in the denominator, we have time term. So for concentration, we will be using molarity, and the unit of molarity is mole per liter. Whereas for time, it is second. So it will go into the numerator part. Therefore, the unit of rate of reaction will be mole per liter per second. Or if there is some other time frame, we can use mole per liter per minute. Next, we have instantaneous rate of reaction. Now, what does it mean? It means that the delta T, which was considered in your average rate of reaction for a greater time interval, here we are keeping that time interval to approximately 0. How can we understand this? Suppose you are riding a bike, okay, and you are covering 2 kilometer in 60 seconds. So how you will calculate the speed? It's very simple, distance by time. Got it? So that is your average rate of reaction. Now what will be the instantaneous rate of reaction? So while driving your bike, suppose you looked upon the speedometer, means the panel of your scooter or your vehicle where you see the speed, and at that instant your speed was 60 km per hour. Now you are defining here the speed at a particular instant. Therefore, we call it as instantaneous rate of reaction. And when we divide it for a large interval of time, when we take the distance divided by time for a large interval of time, we call it as average rate of reaction. As simple as that. Now, how do we define it? It's very simple. R instantaneous is small change in the concentration with respect to small change in time, and that will be according to the reactant and product. So if you are considering it for the reactant, which is A, you will put a negative sign here because rate can never be negative. So you can simply consider the example of your speed of your bike. So you have never known that speed is negative. So that is something which is not possible. Similar to that, rate also cannot be negative. But if you are considering the reactant, then the final concentration of the reactant will be obviously less because it is consumed during your whole reaction course. And when you will subtract final minus initial, you will get a negative value. Now to keep the rate of reaction in a positive sense, you put a negative sign here. But in terms of product, of course, the product concentration is increasing. The final concentration will be greater than the initial one, and therefore it is final minus initial without any sign against it. Got it? Now what is the difference between these two? Here we are using delta. Now delta refers to a greater change, and when this delta t is approximated to 0, or when the limit delta t tends to 0, at that case, in that case we take the differential. Okay, we take dt here. Got it? And you must have seen this in your differential calculus also, where you start with a function and see its change for limit delta t, limit delta x equals to it tends to 0. Okay, similar to that, here we are taking the change in time as approximately equals to 0. Next, can we define it for a general reaction? Yes. Suppose this is your reaction where you are going from a plus b to x plus y, where small a, small b, small x and small y, these are the stoichiometric coefficient which are there to balance the equation, and capital A, capital B and capital X and capital Y are representing the reactants and products respectively. So how do you define the rate? Everything will be similar to the previous one apart from the coefficient. So here also we have taken the coefficient in A to B, but since the coefficient is 1, so we are not seeing its resemblance in the final equation. But if its coefficient is other than 1, like here it is A, so we have to divide it by A. See, the rate can be now written as minus 1 by A, small a, d A d by dt, where dA is representing the change in concentration of A. So whenever you are seeing a product concentration change, you are seeing a positive sign here. And if you are seeing a reactant concentration change, you will see a negative sign here. Got it? And you will divide this whole thing by A or B, which is your stoichiometric coefficient, or X or Y for the product's stoichiometric coefficient. And this is the most important part you should remember. Now, an important term which is to be remembered through the numerical analysis is the rate of disappearance and the rate of appearance. If you only take minus dA by dt rather than minus 1 by a dA by dt, then that would be your rate of disappearance of A. Similarly, if you take minus dB by dt and you don't take this 1 by B, that would be rate of disappearance of B. Now, if I write it in terms of product, then dx by dt will be your rate of appearance of x and dy by dt will be your rate of appearance of y. Got it? So when you divide your rate of appearance or disappearance with the stoichiometric coefficient, you get your rate of reaction. Any doubt in this part? So this is very, very important and it is used to solve numericals in chemical kinetics. Is it clear to all of you? Any doubt in this part? Anyone? Okay. So I am assumed that it is clear to all of you. Moving on to the next part. So what did we studied here? So we studied two things: so average rate of reaction and instantaneous rate of reaction. And I said that instantaneous rate of reaction is something which is important and it will be used in your upcoming slides. And what is the difference between these two? In average rate of reaction, we consider the rate over a large interval of time, whereas in instantaneous rate of reaction, we see the rate of reaction for a small instant of time. And to write it in terms of rate, what do? We divide your disappearance or appearance rate with the stoichiometric coefficient. What is the disappearance rate here? For A, it is minus dA by dt, and we divide it by its stoichiometric coefficient small a to get the rate of a reaction. We can think of it in the similar way for the B, X, and Y species. Okay. Now, moving on to the factors which affect the rate of reaction. So there are several factors which are changed accordingly in our day-to-day life to influence the rate of reaction according to our need. Okay. Now, what are those factors? First of all is concentration. Okay. So we have seen it from your Lee-Chatterjee principle also, that concentration has changed upon the amount of product formed, and it has also effect upon the rate of a reaction, that how fast your reaction will go. Next, nature of the reactant. Of course, you are doing the reaction in acidic medium or basic medium, that will obviously affect a rate of reaction. Third is your temperature. So if your reaction is exothermic and endothermic, that will also affect the rate of reaction depending upon the temperature change you are doing in your reaction, and we will study about in detail in the Arrhenius equation. Then comes your presence of catalyst. So you must have seen that catalysts are introduced into the reaction mixture to promote the rate of reaction. And what does catalyst does? It provides an alternative pathway for the reaction to proceed, which requires a lesser amount of energy to proceed, and hence your reaction rate increases. Okay. Then last we have exposure to radiation. So some reactions are very much successful in the presence of UV light. For example, if you take the chlorination of your hydrocarbon, there you use your UV light to promote the reaction or to promote the homolysis of chlorine molecule into Cl radical. Okay. So that is a specific case where you use your UV radiation to enhance the reaction. Now, we will mainly focus on two things. As I said earlier, we are focused upon, so first of all, this temperature. So that will be studied in the next part of our lecture, which is Arrhenius equation. The first part, which is concentration, it will be discussed today. And that is something which is quantified with the help of your rate law. So, introducing what is rate law. According to rate law, the rate of a chemical reaction is directly proportional to the effective concentration of the reacting species. Suppose if you take the previous reaction, A plus B giving us X plus Y. So you would say that if you increase the concentration of your A and B, then it would enhance the rate of reaction. Now, what is the actual mathematical relation? So for that relation, you have to raise the power of your concentration of reactant to a certain value. Okay. And that value can be or cannot be equals to the stoichiometric coefficient, and that value is experimentally determined. So let us try to understand this thing with the help of a general reaction. Suppose we have a reaction where we are going from reactants capital A and capital B to form a product, and small a and small b are the stoichiometric coefficient. So how do you write the rate law? Very simple. It would be written as rate is equals to K concentration of A raised to the power alpha. So it is not the stoichiometric coefficient that you are seeing in the reaction, it is a different value. So we are representing it with a different constant which is alpha. Okay. Similarly, the concentration of B is represented with a different notation which is beta. Now, this beta can be equals to B or cannot be equals to B. So there are certain criteria for it. We will study about that in the upcoming slides. So what is the K here? K is the rate constant or velocity constant or specific reaction rate. Now we are again seeing a term specific here. Now when does a given parameter becomes specific? When we keep the other parameters as unity. So if you take the concentration of A and B as 1, in that case your rate of reaction will be equals to this K, and that is the reason we call it as specific reaction rate. So this is the reaction rate R, and when the when the concentration of A and B equals to 1, then in that case your rate of reaction become equals to K, which is your specific reaction rate. Then this expression is your rate law. Got it? Is it clear to you? So this is very, very important. So first thing we studied that we can write the rate of a reaction in terms of the concentration change with respect to time and with the help of the stoichiometric coefficient. Here we are writing the rate of reaction in terms of concentration, but the power is not equals to the stoichiometric coefficient. It is an arbitrary value which depends upon the actual reaction, and it is determined experimentally. Got it? Now we said that we have factors affecting the rate of reaction, and among those factors we have two important one which we will quantify in this lecture series. What are those? First one is concentration. So this is defined with the help of this rate law. Okay. So now we are studying the effect of concentration change with the help of this rate law. And when we will study about the temperature change, we will study with that with the help of Arrhenius equation. Got it? So this should be clear in your mind. So we are studying those same factors but quantifying them with the help of certain equations. The first one is the rate law, which help us to quantify the effect of concentration change on the rate of a reaction. Then we have the Arrhenius equation, which help us to quantify the effect of temperature change on a particular reaction. Got it? Now moving on further in this rate law, here are some important points related to it. First of all, rate law is never deduced from your balanced equation until and unless there is a specific information which is to be displayed in the equation. So that is your elementary or your complex reaction. So if your reaction is a elementary reaction, got it? Means it is happening in that single step. So if your reaction is an elementary reaction, in that case you can directly write your rate law using the stoichiometric coefficient. Means your alpha and beta you have seen right now, to which the concentration terms were raised, that will be equals to the stoichiometric coefficient. But if it is not given in the question that whether the reaction is elementary or not, you cannot make the power equals to the stoichiometric coefficient. Okay. So that is the reason it is written here that rate law cannot be deduced from the balanced equation. It is always determined experimentally. Next, what is the rate constant of a reaction, which is your K? It is defined as the rate of a reaction when the concentrations of all the reactants is taken as unity. Means it is taken as 1 mole per liter. Now what is the unit of K? So this is very important. From here questions are asked and it is very easy to determine this. How do we determine this? So if you just write the units of rate and A, concentration of A and rate. So what will be the rate? We have started in the we have seen this in the starting part where we saw that rate is the change in concentration with respect to time. So from that formula it will be mole per liter per unit time. And what will be the unit of concentration? So it will be obviously mole per liter, but it will be raised to a certain power which is n. And depending upon the power of this n, we will get various units for k. So if you just reduce it further, it will be k is equals to mole raised to the power 1 minus n. So you can just bring this part here from the right side to the left hand side, and you will see that mole will be having a power of 1 minus n. Okay. Then liter will have a power of n minus 1, and second will have a power of minus 1. So here time is in the denominator. So when it will go into the numerator, it will have a minus 1 power. Now this is a general equation which can be used to get the unit of rate constant of a reaction for different types of reaction depending upon the power which we are getting here. Now in the next upcoming slide, we would come to know that what is this power. This power is basically the order of reaction. We will see it. So n is called as the order of reaction. Okay, so this experimental value which we are talking about is nothing but the order of reaction. So now we will study this in detail. What is order of reaction? The sum of the power of all the reacting species that are involved in the rate law is equals to the order of that particular reaction. Let me define it in simple terms. So we will take that same reaction, a plus b going to x plus y, with particular coefficients as small a, small b, small x and small y respectively. So according to rate law, we can write the dx by dt is equals to k a raised to the power alpha and b raised to the power beta. So this is basically your rate of reaction dx by dt, and this x and x are not equal obviously. So do not confuse in this. It is simply your rate of reaction. Okay, as simple as that. Now, since it is the rate law, because we are writing it directly proportional to the concentration of different species, so this alpha and beta will be the overall order of reaction. So if you add your alpha and beta, this will give you the overall order of the reaction a plus b going to x plus y. Is it clear to you? So in the previous reaction, if you see, we have taken r is equals to k raised to the k into a raised to the power n. So there a single species was involved and its power was equals to n. Therefore, n will be equals to the order of reaction. But here multiple species are involved, and for each of them we have different power. For A we have alpha, for B we have beta. So for the overall order of reaction, it would be alpha and beta. Now someone asks you that what is the order of reaction with respect to A. So here we are not telling that we are interested in overall order of reaction. Suppose you are interested with respect to a certain species. Now let me tell you what will be the value in that case. It will be alpha. So the overall rate of reaction is alpha plus beta, whereas the rate of reaction with respect to the species A is alpha and with respect to the species B is beta. I guess this clear to all of you. Next, as said earlier, since alpha and beta are experimental value, so the overall order will be also an experimental value, which is the sum of alpha and beta. Therefore, we can conclude that the order of a reaction can only be determined experimentally. I hope this is clear to all of you. Anyone who has a doubt in this part? Is it clear to all of you? So if you have a doubt, you can just post it in the comment section. So far, we have studied about the rate law, which defines the change in rate of a reaction with respect to the concentration. And in that, we have studied about the order of reaction, which is basically the power addition of all the concentration term of the reactants in the rate law. And the specific value alpha and beta are the order of reaction with respect to the species A, and beta is the order of reaction with respect to the species B. Got it? So if you have a doubt, you can just post it here, or if you are facing difficulty further after this lecture, you can just come on our SATHEE website. We have a doubt clearing session there, or you can just join our SATHEE forum, and there also you can post specific questions. We will try to answer them as quickly as possible. Next, moving on to molecularity. So what is molecularity? You must be getting a literal sense of this term. Let me define it for you. It is the number of ions or molecules which take part in a elementary process. What is the meaning of this? Suppose you have two molecules, one is of A and one is of B, and they can collide together to form your required product, which is C. So here what you can say, the molecularity of this reaction that you are seeing right now is 2, because two molecules have to collide to give you the product. Got it? Now this is a very simple thing. Now the question comes, where is the difficulty in this part? The difficulty comes when you have a complex reaction. Got it? Suppose there is a series of reaction which is going on to give you the final product. A is reacting with B or colliding with B to form C, and C is colliding with D to form E. Got it? In this overall complex reaction, you cannot define molecularity for the overall reaction, but for the individual steps, that is collision of A and B and the collision of C and D, you can define molecularity for each step. Got it? So we can say that in simple reaction, known as elementary reaction, molecularity will be simply equals to the number of molecules which is present in a balanced equation. But in the case of complex reaction, you cannot define it in that simpler term. A very interesting fact for you. So consider the case of a reaction. Suppose you are in the reaction mixture and you are going to see a reaction due to collision of two balls or two molecules. So that is something which is highly probable to occur. Now consider the probability of simultaneous collision of three molecules A, B and C. Now this is something which will have a lower probability. Now consider a third case where your reaction will occur due to the collision of four molecules, and that also at simultaneously. Okay, now its probability will be even lesser, and that is something which is observed in our actual reactions also. So molecularity is seen to have a at most value of 3, because the probability of collision of four molecules at a one time is very difficult, and that also requires a certain orientation. Means you won't say that the molecule will just collide and it will give you the reaction. It should have certain amount of energy plus certain orientation, and then only you will get the product, or else the collision will not be your effective collision, it will not produce product. Therefore the molecularity of a reaction is seen to having a value of at most 3 in most of the reactions that we are seeing in our general chemistry book. Okay, next we will see examples on it. So first is your unimolecular reaction, where we are only seeing one molecule which is not undergoing any collision. It is just decomposing to form two molecules of NO2. N2O4 is giving us two molecules of NO2. So this is an example of unimolecular reaction. Consider the example of bimolecular reactions. So here we have taken the decomposition of HI, where two HI molecules are colliding with each other to form H2 and I2. Third is of trimolecular reaction. So this is the extent we see. The last thing, okay. Apart from this trimolecularity, we won't see a reaction which is having a molecularity of 4. So this is something which is very less in probability. So for trimolecularity, we have the example of 2NO reacting with O2 to give up 2NO2. So here we have two molecules of NO and one molecule of O2 colliding together simultaneously to give us two molecules of NO2. Next, what happens in case of complex reaction? As I said earlier, in complex reaction, molecularity has no sense, because in the complex reaction there are multiple steps. You can define molecularity for each single individual steps, but you cannot define it for the overall complex reaction. Got it? Moving on to the next part. So for complex reaction, order is given by the slowest step. So let me just make it simpler for you. What do you mean by this? Suppose there is a reaction which is going in multiple steps, and you have to know that what is the order of that reaction. So how you will know? You will take the slowest step of that multi-step reaction, and that will give you your order. Now why I am saying it? Why are we considering it for the rate of reaction the slowest one? So take the example of a relay race. Okay, Relay race, you know it. What is relay race? So where a group of people are racing for one single race. Okay. And in that process, we pass on a stick, and the one who reaches first wins. Okay. Now, three people are there. There are a group of three people. They are doing a relay race. Two are fastest, and the one is slower. So the faster one will not be the deciding factor. If the one who is running the slowest, if he does better, then you win the relay race. So in that similar fashion, suppose three-step reaction is there. Two steps are occurring in 10 seconds, and the third step is occurring in 10 days. So in comparison to that 10 days, your 10-second has no effect. Therefore, while determining the order of reaction, we take that slowest step rather than taking the other two faster steps. Got it? I hope this is clear to you. Now, a very important thing, just note it down. So, for a complex reaction, the stoichiometric coefficient is not equals to the order of a reaction. Whereas, I said it earlier, in some cases, the stoichiometric coefficient is directly equals to the power. And that thing is true for elementary reaction. What are elementary reaction? That occurs in a single step. And you will be given this thing in your question. Got it? Now, moving on to molecularity. Suppose we have a reaction that takes place in three steps. The first step is HbRO3 reacting with Hi to form HbRO2 and HiO. Now, consider this first step as the slowest step. Next, your HbRO2, which is formed in the first step, it will again react with another 4 molecules of Hi to form HBr, 2H2O and 2I2. But this step is faster. Consider the third step. Your HiO, which was formed in the first step, it will react with Hi to form H2O and I2. And these are three steps. Now, if I ask you that what is the order of reaction, how you will tell it? As I said earlier, to always look upon the order of a reaction, we will look upon the slowest step. So here the first step is the slowest step, and the overall molecularity of this reaction will be equals to the order of the reaction. So if I write the rate law here, it will be rate is equals to HbRO3 raised to the power 1, means the concentration of HbRO3 raised to the power 1 multiplied by the concentration of Hi raised to the power 1, because the stoichiometric coefficient is 1, and we know it already that this step is the elementary step and the slowest step. So it will define the order as well as the rate law of the particular reaction. So since the power is 1 for both of them, therefore the overall order will be 2, and hence this reaction will be a second order kinetics. Got it? Now some important points regarding the difference between order of reaction and molecularity of reaction. So order of reaction will will depend upon the pressure and temperature and other factors. So it may vary, but molecularity is something which is fixed. So if you have to form a given product C, you have to have collision between A and B, and then only you will have the C. Got it? So it will be constant. Its value will be constant. Next, molecularity will be having a value of whole number always. Why is it so? Because you can't have a half molecule, right? You can't have a negative molecule. You will always have a positive integer. Got it? And there will be collision between two molecules, or either three molecules, or either four molecules. So that depends. That is pretty not possible. But still, molecularity can only be a whole number, and that also not equals to 0. Got it? It can never be 0, negative or fraction, because a molecule can never be in half condition or in negative condition. Whereas order of a reaction has no such constants. It can be a whole number, a fraction, a 0, or even negative. So these are some very important points regarding the difference between order and molecularity of a reaction. I hope this is clear to you. So what we studied so far, we studied that order of a reaction is something which is determined experimentally, until and unless we don't know that that given reaction is elementary or not. If that reaction is elementary, then in that case, the order of reaction is simply the stoichiometric coefficient. As we have seen here, in this case, the order of a reaction is simply the rate is equals to HbRO3 concentration raised to the power 1, Hi concentration raised to the power 1 multiplied by the rate constant, which is K. And since both of them have power 1, therefore this is a second order kinetic. So it is given in the given description, it will be given that this particular step of the reaction is an elementary one and the slowest one. And therefore we can derive or deduce the rate law directly from this step. Got it? Okay. Next, if this is clear to all of you, the order of a reaction, we will take a specific example of a zero order reaction. Okay, so this is the first type. We will study three types: zero order, first order, and second order. So, first of all, what is zero order reaction? Now, the reaction in which the concentration of reactant has no effect on the rate of reaction means whether you change the rate of reaction, whether you keep it, whether you change the concentration of reactant or whether you keep it constant, your rate of reaction will be always same, because the dependency of the rate of a reaction on the concentration of your reactant is having a power of 0. Okay, and these reactions are known as zero order reaction. For example, if we take a hypothetical reaction, considering that your given reaction is zero order, so we are going from R to P and this is a zero order reaction. So how do we write the rate law? Very simple. So rate will be equals to minus dr by dt is equals to k into r raised to the power concentration of r raised to the power 0. Now what you can see here. So this equation that you are seeing right now is the rate law for this particular reaction if this reaction is zero order in nature. How we are knowing it? Because we have raised the concentration of R to 0 power. See here, we are raising the power to 0. So we can say two things here. First thing, that this reaction is 0 order with respect to the species R. Second thing, since only species R is involved in the reaction, therefore overall order of this reaction is also 0. Got it? Any doubt in this? So this is very important to understand that how do we write a rate law using a particular reaction if its order is already mentioned in the question. One more important thing, since we are writing the rate law and we are using the differential part dr by dt, how are we writing it? It's very simple, change in concentration of reactant with respect to time, and since the stoichiometric coefficient is 1 here, therefore no term will be divided with this given term. Okay, so suppose it was 2r here, then in that case it will be minus 1 by 2 dr by dt. But since the stoichiometric coefficient is 1, so we don't need to put any number. Second thing, we have to put a negative sign here because we need to keep the rate of a reaction as positive and the concentration of reactant is constantly decreasing. Therefore, final minus initial will give you a negative value, and to keep the rate of a reaction as positive, we have to keep this negative sign against it, and I have already discussed this thing earlier. Got it? Now, moving on further, if you just integrate this given equation, so you can just try it by yourself, take your limits between 0 to t. Okay, so for time you take it as 0 to t, and for concentration you take it as C0 to Ct. Okay, so C0 will be the initial concentration and Ct will be the final concentration at time t. In that case, if you just integrate that term, you will get it as k is equals to minus Ct by minus C0 by t. Okay, it's very simple. First of all, just separate the variables. So here we have R term here. Okay, do we have any R term in the overall equation apart from this? No, because since this concentration is raised to the power 0, it will be equals to 1. As simple as that. Then you bring this dt from this left hand side onto the right hand side, so it will be k dt. Then after you just integrate it, for concentration of R, you take it from C0 to Ct, and for time you take it from 0 to t. That means at t is equals to 0, means initially your concentration was C0, and when you take it to time t, the concentration is Ct. Then if you integrate that thing, you will get it as k is equals to minus Ct minus C0 by t. Now this is known as integrated law, and I hope this is quite clear to you, because this reaction that you are seeing, or this equation that you are seeing, it is something which is differential rate law, because here we are writing in terms of differential form, and when we integrate it, we get it as integral rate law. Very simple to understand, right? and you will be asked in the exam to just apply this thing. Means directly there will not be a question, but it will be given that use the differential rate law or use the integral rate law. So in that case, it will help you. Again, how do we define it? So if you're writing it in terms of dr by dt, since they are writing in terms of differentiation, we'll call it as differential rate law. And if we integrate it over an interval of time or our interested interval of time, we write it as integral rate equation. This is for your zero order reaction. Got it? Next, what is C naught here? As I said earlier, C naught is the initial concentration of the reactant and Ct is the concentration of reactant at any time t that we have considered. So this is a very important point. Now I am giving you a task. Just try to draw a graph. Okay, try to draw a graph between your rate of reaction and K. R, sorry, concentration of R. As I said earlier, so in zero order reaction, the concentration of your reactant has no effect on the rate of reaction. So if you take a graph between rate and R, you will see a straight line which will be parallel to the rate of reaction axis. Sorry, concentration axis. Yes, hi Hyper. So if you have a question, you can just post it here regarding this. So anyone who has a doubt till this part, you can just try your integration right now if you want. It's very simple integration. Just arrange the variables according to the differentiation part and just integrate it for 0 to t time where the concentration is going from C naught to Ct. Anyone who has a doubt till this part? So after this, we will do questions on the same. Is it clear to all of you? Okay. So moving on forward with this zero order reaction. Next, we have half life. So what is half life? If you try to define it very simply, it is the time at which the initial concentration of your reaction is being consumed to its half. Okay, suppose you took your reaction at that point where your reaction mixture was having a reactant concentration of 4 mole per liter, and you noted the time until your concentration becomes 2 mole per liter. So the time difference which your reaction took for going from 4 mole per liter to 2 mole per liter is your half life. As simple as that. Means it is the time which is required for the concentration to become half of its initial value. Got it? Now, if this is the case, then what will be the half life for a zero order reaction? Take the previous equation. What was the previous equation? K is equals to minus Ct minus C naught by K. Okay. Now, if you take the concentration equals to half of the initial stage, that means concentration at time t is equals to C naught by 2. Got it? Means half of the initial case. So just put the value of Ct as C naught by 2 and try to find out the time variable. Now in that case, you call your time as t half. Okay, you represent your time rather than using t, we will use t half for the half life of a reaction. Then next, here what is K? We know it very well. It is the rate constant and T half is the half life of a reaction or half life period. Both are same. They are used in place of each other. Next, if I just try to write the unit of rate constant, suppose for a zero order reaction. So we have already seen a general equation to derive the unit of a given rate law of particular order. So here we are interested in finding the unit of rate constant for zero order reaction. If you just try to find it out, it will be mole per liter per second. Okay, it's very simple. Just start from your initial rate law, which is rate is equals to K into 1. Okay, because we are raising it to the power of 0. Now, whatever will be the unit of K will be the unit of your rate. Got it? And what is the unit of rate? It is mole per liter per second. So, the unit of K will be also mole per liter per second. I hope this part is very clear to you and quite simple as well. So, you must have studied this thing in the in deriving the units. Okay, so we have seen the derived unit part in the physics. So, you will use that same concept here using the rate law to define your unit for different rate constant of different order depending upon the value of order of reaction. Try to find it for the first order reaction and for the second order reaction as well. Okay, use again the same rate law. Got it? So rate is equals to K A raised to the power 1. Suppose in case of first order reaction, you will take the power of concentration as 1. So rate will have the same unit mole per liter per second and K multiplied with mole per liter because we have a power of 1. Just take it on to the another side and you will get the unit of K. Similarly, you can try it for the second order reaction as well. Next, what did we study throughout? First of all, we started with the rate of reaction, which is simply a measurement of how fast or how slow your reaction is getting converted from reactant onto product. Now, this can be as slow as 100 years, which is conversion of your carbon fossil into diamond, or it can be as fast as your reaction where you see a decomposition of your HI. Okay, so we have a large time variation. Next, we have rate constant. So, rate constant is what? It is the rate of a reaction when we take the concentration of every reactant as 1. It is also known as the velocity constant or the specific rate constant. And it is a measure of effective collision between your reactant molecule. Then we moved on to the order of a reaction. So, we have order of reaction in two senses. What are those two senses? First of all, you can define it in terms of specific reactant. Suppose we are seeing a reaction of A and B to give us product C. So, we can write the rate law as R is equals to K A is raised to the power alpha, B raised to the power beta. So, alpha is the order of reaction with respect to the species A. Beta is the order of a reaction with respect to the species B. And alpha plus beta is your overall order of reaction. Got it? Next, we have molecularity. So, it is the number of molecules which participate in your rate determining step. Got it? Remember, molecularity has no significance for a complex reaction. It is always defined for a elementary reaction and it can never be negative or fractional or 0. Molecularity can be always a positive integer. Is it clear to all of you? Anyone who has a doubt in this? So, in the next part, we will start our question. So, if you have a doubt regarding the theory part, please ask it right now. Is it clear to all of you? VK, Dhruv, Pratham, anyone who has a doubt in the theory part? Shall we start the question part? Okay. So, just wait for a while. I will just move on to the PYQs right now. So here is your first question. It is given that a drop of a solution whose volume is 0.05 molar contains 6 into 10 to the power minus 7 mole of H plus. Now, it is given that the rate of disappearance of H plus is 6.05 into 10 to the power 5 mole per liter per second. You have to tell that how long will it take for the H plus in the drop to disappear. So what is given in the question? Your rate of disappearance is given, means dH plus by dt. Okay, so this thing is given. Then you are given with the initial concentration. So it contains 6.6 into 10 to the power minus 7 mole of H plus, and the volume is given. So therefore you can calculate the concentration as well. You have to see that how long it will take for the drop to disappear. If you want, you can just comment it in the comment section, or else you can vote it here in the poll that I have generated. I will give you some time, just think over it and write your answer. So basically, in a way, you have to calculate your delta T, okay? Because it is said that your concentration should become 0. Means here it is written H plus should become 0. It should have a 0 concentration, since it is written here to disappear it. Therefore, the final concentration is given away as 0. Initial concentration is already mentioned. Now you have to determine the time it will take to do so, and the rate is also given, rate of disappearance. So you know how to define the rate of disappearance. Just try to solve it. It's very simple. Okay. So moving on to the answer. For those who have solved it, the correct answer is 2 into 10 to the power minus 8 second, option number B. Let us see how can we solve it. As I said earlier, from the given values of mole and your volume, you can calculate your concentration. But before that, you have to convert your milliliter volume into liter by multiplying it with 10 to the power minus 3, because 1 liter is equals to 10 to the power 3 milliliter. Next, you got your concentration of H plus. Okay, so we are seeing option B as the correct. Okay, let's see. Yes, option B is correct. So next, how do you calculate the rate? It's very simple. If you are calculating the rate of disappearance of H plus, then it will be delta X by delta T, which is rate of change of concentration divided by the change of time. Now this is to be calculated. It is written there that how long it will take. Means you have to calculate the time when your final concentrations become 0. So what will be the change in concentration? Initial is 1.2 into 10 to the power minus 2, and final is 0. Subtract it. It will simply the same value divided by the rate which is given is 6 into 10 to the power 5. If you want, you can just cancel out the unit and verify your answer as well. So rather than writing it as mole per liter, we are writing it as capital M, which is your molarity term. Here, your M and M will get cancelled out. Second will go on to the numerator, and you will get your time as 2 into 10 to the power minus 8. Okay, so those of you who have just put the values, I uh, I hope you got the answer, right? So anyone who has a doubt in this part, you can just post it here, or if it is good, you can just give a thumbs up to assure the same. Is it clear to all of you? Anyone who has a doubt in this part? So what we have done, it was given in the question that the rate of disappearance is 6 into 10 to the power 5. The mole of your H plus is given, initial mole 6 into 10 to the power minus 7, which is there in 0.05 milliliter of the solution. You have to say that when will this H plus disappear. So basically you have to make your concentration as 0. So change in concentration will be simply your initial concentration, and your rate is given as 6 into 10 to the power 5 mole per liter per second. You have to determine what is the delta T. Okay. So you just divide it, you will get it as 2 into 10 to the power minus 8 second. Moving on to the next question. It is given that the instantaneous rate of disappearance of MnO4 minus is 4.56 into 10 to the power minus 3 molarity per second. Then you have to decide that what is the rate of appearance of I2. Okay. The equation is already given, 2MnO4 minus 10I minus plus 16H plus. It is giving your product as 2Mn2 plus 5I2 plus 8H2. So what we have to do? We have to find the rate of appearance of I2. Remember, you have seen the rate of reaction and seen that they are only equal if you divide them with their specific stoichiometric coefficient. Okay, just try this out and see what is the answer. If you have calculated it, just comment it in the comment section, or else you can just vote it here in the poll that we have created. How you will write it? If you write it for MnO4 minus, it will be minus 1 by 2 MnO4 minus concentration change divided by the time is equals to 1 by 10 change in concentration of I minus by change in time with a negative sign. Similarly with H plus, फिर Mn2 plus, then I2, and then 8H2. But here we are interested in I2. If you got the answer, just comment it here in the comment section. It's a easy one. Anyone who got the answer? Varsha Khare, option number B. Anyone else? So I will wait for 1 more minute. It's a very simple one. Just try it by yourself. You can use the calculator if you want for the time being. But still, I think that it will not need calculator, hopefully. It's a simple calculation. Okay, one more answer is coming. Khushi Kumari, option number B. Anyone else? So, let us move on to the correct answer. The correct answer will be option number B. Okay, so you are correct. So, let's see how we can solve it. As I said, you can write the rate of reaction equals to their rate of appearance divided by the stoichiometric coefficient, or the rate of disappearance divided by the stoichiometric coefficient. Now, we are interested in two species, for the one which is given and for the one which we have to calculate. First of all, for the one which is it is given, we will write it as minus 1 by 2 dMnO4 minus by dt. So this value is given as 4.56 into 10 to the power minus 3 by 2. So instead of dMnO4 minus by dt with a negative sign, you will put this value. And you have to calculate what? di2 by dt. If you just put this value here, see, we have taken this minus dMnO4 minus dMnO4 minus by dt as 4.56 into 10 to the power minus 3 molarity per second. Then after, if you just rearrange this 5 will go on to this side. So 5 by 2 multiplied by 4.56 into 10 to the power minus 3 molarity per second. Okay. Next, 5 by 2 means 2.5. Just multiply this with 2.5, it will give you 11.4. So finally, it will be 1.14 into 10 to the power minus 2 molarity per second. So this is your final answer, which is option number B. So anyone who has a doubt in this part, is it clear to all of you? Anyone who has a doubt in this part? How are the values coming in the denominator? So they are directly coming from the coefficient, because MnO4 minus has a stoichiometric coefficient of 2, so we have to divide this thing by 2. Similarly, for I2 the coefficient is 5, so we have to divide it by 5. Okay. So moving on to the next question. The rate law for the reaction RCl plus NaOH giving us ROH plus NaCl is given by rate is equals to K multiplied by RCl concentration. So you have to determine that what will be the rate of reaction. First is, if we double the concentration of sodium hydroxide, the rate of reaction will be doubled. First option. Second, if you halve the concentration of alkyl halide, your reaction rate will be halved. Third one, if you increase the temperature of the reaction, the rate of reaction will decrease. So this is something which we have not studied so far. So for the time being, let me just tell it to you that for any given reaction, the temperature is always a good factor. It always increases the rate of reaction. Next one, unaffected by increasing the temperature of the reaction. So this is obviously not true. Temperature has a large effect on any reaction that you take. So these two options are not correct. Now I am leaving it for you to decide between these two options, whether it will be affected by the change in concentration of sodium hydroxide, or it will be affected by the change in concentration of your alkyl halide. You can directly see it from your given rate law. If you just got your answer, just vote it here or comment it here in the comment section. So it's a simple one, I guess. I said it that these two options are already incorrect, since I have not discussed it so far. So I am giving you the clue for it. Okay, so every rate of a reaction increases upon increasing the temperature, and it will always have an impact on the reaction. It's not possible that your reaction rate is not impacted upon changing the temperature. Okay, so I will wait for one more minute, then we will move on to answer. So option number B, option number B. Anyone else? Partham, BK, if you are there, you can just reply it in the comment section as well. So I got two answers already from Varsha Khare and Kushi. Option number B. Okay. So I hope you all got your answer. So moving on to the correct answer. The correct answer will be option number B, which says that if you halve the concentration of your alkyl halide, your reaction rate will also be halved. You can try to solve this question mathematically. So that would be more important and more effective, because you will not get simple questions like this possibly. So try to find two rate of reactions. First, you take the rate of reaction in that condition where your concentration is RCl. In the second case, you take the concentration as 2 RCl, because you are doubling it, right? Sorry, you are taking it a half. So half RCl. Now divide both of the equation, name the first rate as rate 1, second one as rate 2, and try to find the relation between the two. So when you will do so, you will see that if you just take this rate equation, rate is equals to K into RCl, then you will find that since your rate of reaction is being halved, because you are decreasing the concentration of RCl to half. And it's very, very obvious. Since your rate law has no dependence of NaOH, it is not given in the rate law anywhere that you have NaOH in it. Therefore, you can easily say that your rate of reaction will not depend upon the sodium hydroxide's concentration. Okay. So this is very, very important, and it's very easy at the same time, because it is already depicted in the question that your rate will only depend, means the rate of reaction will only depend upon the RCl. And I said that two of the below options, which are temperature dependency, is absolutely wrong. So you have to decide between the first two. And the first one says that it depends upon sodium hydroxide, which is not true from, again, this rate equation, rate law. Now moving on to the next question. I hope this one is clear to you. So this is something which is to find the unit of the rate constant for a second order reaction. Four options are given here. You can just easily derive it from the rate law. So I am giving you some time to solve it. Please try to solve it by yourself. And if you are solving it, just please comment it in the comment section, or drop your poll in the poll out. Okay. So your time starts now. I am giving you 2 minutes to solve it, since it's an easy one. We will start the solution part in 5 or 10. You don't have to worry. This is not a question of second order kinetics. It's very simple. If you know the basics of your rate law, you can easily determine the unit of your given order. It can be of any order. If you know the rate law, you can easily derive it, because you know already how to derive the derived units. Okay, we have seen this type of questions in physics also, where you try to derive it. If you know the rate law, just put the values there. Here the order is given as 2. Therefore, you will take the concentration power as 2. So I would expect more answers from you. Right now I'm seeing 3 votes only. So I would pressurize you to vote more in this section. Okay. Okay. So moving on to the answer. So I am seeing option C as correct. Let's see if it is correct or not. So correct option will be option number C. How we'll solve it? It's very easy. First of all, we will write the rate law for a second order kinetics. Of course, we are unaware about the integrated rate law, and it is not needed at the same time to write the unit. What we will use? We will use the differential rate law. So that would be dx by dt is equals to k concentration square times. Why is concentration square times? Because it is given in the question that this is a second order reaction. Okay. So for second order reaction, you will take here power as 2. Is it clear? Is this rate law clear to all of you? Anyone who has a doubt in this rate law? It's the most important part, and the crucial part as well for your overall chapter. Okay. You must know at least to write the rate law. So this is this part clear to all of you? Anyone who has a doubt in this part? Okay. So I hope this is clear to all of you. Next, we will just rearrange this equation. What do we want? We want the rate constant unit. What will be the unit of this dx? It is the change in concentration. So we will write the unit as concentration. Simple. Then in the denominator we have the time, because change in time will have the units of time. It's very simple. If you subtract 5 seconds from 2 seconds, you will get it as 3 seconds, which is having a unit of second as well. Okay, so that is very obvious. The unit will not change upon addition or subtraction. It will only change upon multiplication and division. So change in temperature will time will be having a unit of time. Then if you bring this concentration onto the left hand side, this will be going on to the denominator. Next, try to simplify it. So concentration will go to the numerator, and 1 minus 2 will give you a power of minus 1. Then after, time will also go in the numerator, and time will have a unit of will have a power of minus 1. Next, what is the unit of concentration? It is mole per liter, or if you write it in terms of decimeter, it will be mole per decimeter cube. Next, since the power is 1, it will be reversed. So mole will have a power of minus 1 now, and per decimeter cube will be converted to decimeter cube. So when we just introduce this minus 1, we multiply it throughout the power, and that will give you decimeter cube per mole. Then what is the unit of time? According to the options, you will keep it as per second. So this will change according to the option, this thing. And here it is given as second. So therefore the total unit will be decimeter cube per mole per second. I hope this is clear to all of you. So if you are if you are seeing that you are getting the question, please send a thumbs up so that I can get an assurance that you are all getting my point. Okay. So if you have voted it wrong, now is it clear to all of you, or still you have a doubt in this part? Anyone who has a doubt here? Okay. So I am assuming that it is clear to all of you. Next question. Question says that, so this one is a good one. So for the reaction system, 2NO plus O2 is giving us 2NO2. Here what are we doing? We are reducing the volume to half its value. And how are we doing it? By increasing the pressure. We know it very well that pressure is inversely proportional to volume. So if you increase the pressure, that means your volume will be decreased, and here it is getting it to its half value. Now it is given in the question that your given reaction is of first order with respect to O2. Remember, we have talked about this, that how can we define order with respect to specific reactant. So with respect to O2, the reaction is of first order, whereas with respect to your NO, the reaction is of second order. Got it? Now you have to determine that what will be the rate of reaction. What effect will it have on the rate of reaction? How you will do it? So let me give you a hint. For writing the rate of a reaction, you use the concentration term. So here what you will do, you will take concentration as mole per liter, or your moles per volume, and change the volume accordingly, which is given in the question. Okay. So volume will be same for all of these species, because all of these three species are in the same reaction mixture. Therefore volume will change for all of them. Okay. Moles are not being disturbed at all. Only you are changing the volume. Just try to write the rate law at two different situations. First, initially you are taking a volume V, and in the second condition you take the volume as V by 2. Okay, so I am giving you some time to solve it. Please do it and write your answer in the comment section. Khushi Kumari, Varsha Khare, VK, Partham, Pratham. Anyone, if you got the answer, just please comment it here in the comment section. So this will be the last question of today's class. In few minutes, our maths faculty will join you. Is it clear to all of you? Any doubt in today's class or regarding any question that we have dealt so far? So, moving on to the answer. We are seeing option B as the answer. Let's see if it is correct or not. So, the correct answer will be C. Okay, no issue. We'll see how to solve it. So, let us take the first situation. I said it, you should keep your initial volume as V. Okay. According to the given data, your given rate law will be written as dx by dt, which is your rate of reaction, is equals to k, which is the rate constant, and NO will be raised to the power 2 since the order is of 2 with respect to NO, and with respect to O2 it is 1. So the overall rate law will be R is equals to k NO square O2. Then next, you can write the same thing in terms of concentration for number of moles and volume. So in place of concentration of NO, we will write it as number of moles of NO divided by the volume. Since it is square time, so it will have the power of 2. Then we can do the same for O2. So this is your initial rate of reaction. Now what are we doing? We are reducing the value of volume by 2. So do it the same in the equation as well. Okay, so we have write it in a simpler form. So we have taken V into V square as V cube, and this is kept as same. Next, what is the next condition? In the next condition, if you write this equation again, this above equation, where you take the volume as V by 2. So here what we do? We take the volume as V by 2. Okay. Now just rearrange this equation. What will happen? This 8 will go here. So 2 raised to the power 3 will give you 8. So this will go here. Now this overall part apart from 8 will be equals to dx by dt. So this is your new rate, which is dx by dt dash. Okay, which we got upon reducing the volume to its half value. If you compare this value and put it here, what you will get? You will get it as 8 multiplied by dx by dt. Means now the rate of reaction is becoming 8 times in its initial value. So what we have done here is we are simply taking the value as V by 2 rather than V, since it is given in the question. And then we are substituting this whole value, which is K multiplied by number of moles of NO square times number of moles of O2 divided by V cube. So this overall value is dx by dt. We put it here and we take this 8 in the numerator, and that gives us your correct option as C. So this was all for today's class. Thank you for joining the session. I hope you enjoyed it. If you have a doubt regarding this chapter or any other chapter, you can just ask it in the next class, or you can come to our live doubt clearing session. Then after, you can also post your question in the SATHEE forum as well. Thank you.
Hello everyone. So welcome to Crash Course. Today we will discuss indefinite integral. At first we will cover theory portion and then we will practice some question based on indefinite integral. So according to last 8 year, chapter weightage of integrals is 7.23% for JEE Mains examination. So as weightage is very high, so this chapter is important for exam point of view. Just wait. And if you analyze year-wise data, so in the year 2024, two questions came from the topic definite integral based on fundamental theorem of integral calculus of average level. In the year 2023, again two questions came from the topic evaluation of indefinite integral and definite integral based on the particular formula, that is integral of e the power kx fx plus f dash x dx of average type. In the year 2022, again two questions came from the topic properties of definite integral and integral of some particular fraction. Two questions came to the year 2021 based on partial fraction, evaluation of definite integral. One question in the year 2020 based on evaluation of definite integral, and total 4 questions came from the topic integral in the year 2019 based on evaluation of definite integral and indefinite integral. Okay, and again two questions in 2018 and two questions 2017. So on average, two questions came each year from this topic indefinite definite integral. Okay, so we start with integral as an antiderivative. We understand what is antiderivative for a function fx. Okay, and how we can relate integral with antiderivative. We already know what is differentiation, so we just relate integral with differentiation. Okay, then properties of indefinite integrals, some fundamental integration formula. After that, we will discuss method of integration. There are many methods for integration, so we will discuss all methods. Okay, so first thing is integral as an antiderivative. So let's suppose we have a function fx. So what is antiderivative? So another function phi x is called antiderivative for this function fx if differentiation of phi x is equal to fx. Okay, so if your function phi x satisfy this condition, that is when we differentiate your phi x we get the function fx, then that function phi x is called antiderivative of function fx. Okay, and one important thing is antiderivative is not unique for a function fx. There can be more than one antiderivative, but if let's suppose there are two antiderivative for a function fx, f1x and f2x, then this both function f1x and f2x is just differ by a constant. Okay, so we can write f1 and f2 as constants plus like f1x is equal to f2x plus c. So they are just differ by a constant. Okay. And when we collect all the antiderivative for a function fx, then that collection of all antiderivative is called indefinite integral. So what is indefinite integral? Indefinite integral is an antiderivative. It is a collection of all antiderivative for a function fx. And how we denote it? We denote it by this sign, integration of fx dx. Okay. So for a function fx, phi x is an antiderivative. If we differentiate phi x, then we get fx. Okay. Now, as indefinite integral is collection of all antiderivative, and antiderivative is just differ by a constant. So any antiderivative can be represented as phi x plus constant c. When we take different value of c, we get different antiderivatives. And by the definition of antiderivative, we know that when we differentiate antiderivative, you get a function fx. So d by dx of phi x plus c, an antiderivative, when we differentiate it, we get a function fx. Differentiation of phi x is phi dash x, that is fx, and differentiation of constant function is 0. So we get d by dx phi x plus c is equal to fx. And it imply when we integrate fx dx, so indefinite integral of fx, that is integration of fx dx, is equal to phi x plus c. Okay, and this is the value of indefinite integral, that is collection of all antiderivative. Clear? So here phi x is an antiderivative and fx is known as integrand. Fx is the function we integrate, and that is known as integrand. And c is an arbitrary constant, that is also known as constant of integration. Okay, and one important result, antiderivative of odd function is always even and antiderivative of even function is always odd. Okay. So let's discuss some properties of indefinite integral. First one is when we integrate fx plus minus gx dx. So here integrand is fx plus minus gx. So integration is distributed over addition and subtraction. So we get integration of fx dx plus minus integration of gx dx. Clear? First property. Second property, integration of k time fx dx. K is a constant and it is a non-zero real number. So integration of k time fx dx is equal to k into k times integration of fx dx. Okay, that is, we can take out the constant term from the sign of integration. So we get k time integration of fx dx. Now when we combine first and second result, we get our third result, that is integration of k1 time f1x plus k2 time f2x plus dot 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 plus kn time fnx dx. So just apply first and second property, we get k1 into integration of f1x dx plus k2 into integration of f2x dx plus dot 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 plus kn into integration of fnx dx. Okay, where this k1, k2 and kn are non-zero real number. Okay, so some fundamental integration formula. Let's recall some formula of integration. So first one, that is algebraic formula, also known as power rule of integration. When we integrate x the power n dx, we get x the power n plus 1 by n plus 1 plus c, constant of integration. One important thing, n is not equal to minus 1. Okay, and integration of ax plus b the power n dx is equal to 1 by a into ax plus b whole power n plus 1 by n plus 1 plus c. where n is not equal to minus 1. We can solve this integral and prove this formula by just using the substitution method. We can take x plus b as new variable and apply the substitution method. We get the formula 1 by a into ax plus b the power n plus 1 by n plus 1 plus c, where n is not equal to minus 1. Third one is integration of 1 by x dx is equal to log mod x plus c. Here, first formula, that is integration of x the power n dx is equal to x the power n plus 1 by n plus 1. And one important condition is n is not equal to minus 1. So if n is equal to minus 1, then we get third one, that is integration of 1 by x dx. And for this, integral is log mod x plus c. Fourth, integration of 1 by ax plus b dx is, just take ax plus b as new variable, use the substitution method. So the fourth formula reduced to third one and apply the third formula. We get 1 by a log mod ax plus b plus c. Okay. Fifth property, integration of 1 by a square minus x square dx. The fifth formula is equal to 1 by 2a log mod a plus x by a minus x plus c. Okay. These are the special type of integration. We can prove all this and we get this formula, that is integration of 1 by x square minus a square dx is equal to 1 by 2a log mod x minus a by x plus a plus c. Next formula, integration of 1 by a square plus x square dx is equal to 1 by a tan inverse x by a plus c. Okay. To solve problem, we need to remember all this formula. Okay. Next formula, integration of 1 by x square minus a square dx is equal to 1 by 2a log mod x minus a by x plus a plus c. Next, integration of 1 by root under x square minus a square dx is equal to log mod x plus root under x square minus a square plus c. Okay. Integration of 1 by root under x square plus a square dx is equal to log mod x plus root under x square plus a square plus c. Okay. Next one, when we integrate 1 by root under a square minus x square dx, special type. So for this, integral value is equal to sine inverse x by a plus c, and integral of minus 1 the power 1 minus 1 by root under a square minus x square dx is equal to cos inverse x by a plus c. Next, integration of 1 by x into root under x square minus a square dx is equal to 1 by a sec inverse x by a plus c. Integration of minus 1 by x into root under x square minus a square dx is equal to 1 by a cosec inverse x by a plus c. Next one, integration of root under a square minus x square dx is equal to x by 2 into root under a square minus x square plus a square by 2 sine inverse x by a plus c. Next, integration of root under x square minus a square dx is equal to x by 2 into root under x square minus a square by 2 log mod x plus root under x square minus a square plus c. Next special type, that is integration of the type root under x square plus a square dx is equal to x by 2 root under x square plus a square by 2 log mod x plus root under x square plus a square plus c. Okay. So we have to memorize all this formula so that when we solve the problem based on indefinite integral, we can directly apply this formula to find the value of integral. Okay. Now, some formula based on trigonometric function. First one, when we integrate sin x, integral of sin x is minus cos x plus c, and integration of cos x is sin x plus c. What about integration of 10x? Integration of 10x is minus log cos x plus c, log mod cos x plus c. We can also write minus log mod cos x plus c as log mod sec x plus c. How? Because it's minus sign, and if we write log sec x as 1 log 1 by cos x, and we know that log a by b is log a minus log b, so we get log 1 minus log cos x plus c, and minus log 1 is equal to 0, so we get minus log mod cos x plus c. In a similar way, when we integrate cot x dx, the formula is log mod sin x plus c, and also minus log mod cosec x plus c. Okay. Integration of sec x dx is equal to log mod sec x plus 10x plus c, and that is equal to log mod 10 pi by 4 plus x by 2 plus c. Integration of cosec x dx is equal to log mod cosec x minus cot x plus c, and that is equal to log 10x by 2 plus c. And integration of sec square x dx is equal to 10x plus c. Clear? These all are the antiderivative. The value of indefinite integral is equal to collection of all antiderivative. So 10x is one antiderivative, and 10x plus c represent the collection of all antiderivative. It means when we differentiate 10x, we get sec square x. Okay, that is the definition of antiderivative. So when we integrate sec square x, we get 10x, and when we differentiate 10x, we get sec square x. So indefinite integral is a inverse of differentiation, that is antiderivative. Now next one is integration of cosec square x is minus cot x plus c. Integration of sec x into 10x dx is equal to sec x plus c, and integration of cosec x into cot x dx is equal to minus cosec x plus c. Now formula related to exponential function. So first one is when we integrate exponential function, we get a same function. So integration of exponential function ex is equal to ex, and differentiation of exponential function ex is also ex. Okay, unique function. And integration of e the power ax plus b dx is equal to 1 by a into a the power ax plus b plus c. Next one, integration of ax dx is equal to ax by log base ea plus c, where a is greater than 0 and a is not equal to 1. Next, integration of a the power bx plus c dx is equal to 1 by b into a the power bx plus c by log base ea plus c, where a is greater than 0 and a is not equal to 1. So these are the formula related to trigonometric function and exponential function. So now we discuss method of integration. There are different methods for integration. So first one is integration by substitution method. So here you use substitution, we substitute for differentiation. So what we substitute? So this method is based on we use a substitution so that our integrand becomes some standard integral, so that we can directly apply the formula. Okay. So the method of reducing a given integral into one of the standard integral by a proper substitution is called a method of substitution. and we have the formula of substitution, standard integral, as I already discussed in earlier slide. So method of substitution is just we use a proper substitution so that our integrand, our integral become in a standard integral where we can apply the formula to find the value of integration. Okay, like we want to integrate of this form, that is integral of f into gx into g dash x dx. So here we can use a substitution method to transform this into a simple standard integral where we can apply the formula. And what we substitute? We just take the function gx as t. First there is a composition of function, so we want to reduce in simple function, so we just take gx as variable t. So when we substitute something with new variable, then we have to change the complete integral of term of x with term of t. Okay, so we just substitute gx is equal to t. Why we take gx as t? Because when we differentiate it with respect to x, we get g dash x dx is equal to dt. So in place of g dash x dx in the question, in the form, in the integrand, now we can write dt. Okay, so now my given integral is become integration of ft dt. In place of gx we write t, and in place of g dash x dx we write dt. So this integral of this form, by simple substitution gx is equal to t, it transformed to integration of ft dt. Okay, so by using substitution, when we integrate, integration of fx the power n into f dash x dx. So this is of the form integration of f gx into g dash x dx. So when we substitute this fx, function fx as new variable t, we get, when we differentiate that, we get f dash x dx as dt. And when we apply the substitution and then apply the algebraic formula, that is integration of x to the power n is x to the power n plus 1 by n plus 1, then we get integration of fx to the power n into f dash x dx is equal to fx to the power n plus 1 by n plus 1 plus c. And if we know the formula of integration of fx dx as phi x, and we want to calculate integration of f ax plus b dx, then we can use the integration of fx dx as phi x. We can write it as 1 by a phi ax plus b. Here phi x is the integral, indefinite integral of fx dx. Okay, now to evaluate integral of the form, there is certain specific form, like first one is integral of dx by ax square plus bx plus c, or integration of dx by root under ax square plus bx plus p, or integration of root under ax square plus bx plus c. So if your integral is of this form, integrand is of this form, then how we can integrate? We just write the numerator part ax square plus bx plus c as, just take a as common, so we get a into x square plus b by ax plus c by a. And now we use the completing square method and we write it as a into x plus b by 2 a whole square. To write this form, we add b square minus 4a and subtract b square minus 4a, so we get a into x plus b by 2a whole square plus c by a minus b square 4a. So this is of the type x square plus some constant. Okay, so this form can be reduced in any of the following form. This is standard form. It can be dx by x square minus a square, can be dx by x square plus a square, dx by a square minus x square, dx by root under a square minus x square, or dx by root under x square minus a square, integration of dx by root under x square plus a square, or it can be root under a square minus x square type. or root under x square minus a square type, or integral of root under a square plus x square dx. It can be the previous question reduced to any of this form, and we have the formula for all these 9 type standard form. Okay, we already have the formula for all, so we can directly use that formula to calculate the integral. Okay, now second form, if your integral is of the form integral of px plus q by ax square plus bx plus c, or integral of px plus q by root under ax square plus bx plus c, or integral of px plus q root under ax square plus bx plus c dx. Okay, so if your integral of this form, then how we can integrate? Just put px plus q is equal to a differentiation of ax square plus bx plus c plus b. Okay, that is, we write the numerator part as a into differentiation of ax square plus bx plus c plus b, where we can find this a and b by just comparing the coefficient of power of x on both sides. Then we get a and b. So by using this, we can evaluate this integrals. Okay, now second, integration using trigonometric identity, second method. So in this method, we evaluate our integral of the form like integral of sin mx into cos nx dx, or integral of sin mx into sin nx dx, or integral of cos mx into cos nx dx, or integral of cos mx into sin nx dx. So by using trigonometric identities, we can evaluate this integral. And what are the trigonometric identity? Just list trigonometric identity. The first one, that we can write 2 sin a into cos b as sin a plus b plus sin a minus b. Okay. Second, 2 cos a into sin b is equal to sin a plus b minus sin a minus b. Third, 2 cos a into cos b is equal to cos a plus b plus cos a minus b. And next, 2 sin a into sin b is equal to cos a minus b minus cos a plus b. Fifth one, 2 sin a into cos a is equal to sin 2a. 6, we can write cos square a as 1 plus cos 2a by 2. Okay. Next, sin square a is equal to 1 minus cos 2a by 2. Cos square a minus sin square a as cos 2a. Sin square a plus cos square a is equal to 1. So we can use any of the trigonometric entity to solve the integral of the form, the above all 4 forms. So if the given integral in the product of 2 trigonometric function, we can use this formula sin and cos to reduce it into addition and subtraction of 2 individual trigonometric ratio, and then we can easily integrate that comparing to this product. Okay, and if there is a square term and we want to integrate them like cos square a, so we can write it as 1 plus cos 2a by 2, and we know integration of cos 2a and integration of 1 by 2a. Okay, so that's how we can solve this type of integral. Okay, now we discuss integration of different types of function. There are some different types of function we want to integrate. First one is, if your given integral is of the form integration of sin the power px cos the power qx dx, then how we can integrate, where p and q are rational number. So there are some certain rules. There's certain rules. First one, if p is odd, then substitute cos x as t. Okay, and if q is odd, then put sin x as t. First rule. Second, if both p and q are odd, Then put either sin x is equal to t or cos x is equal to t. And if both are even, then we use trigonometric identities. Okay, we don't need to substitute anything. Now, if p and q are rational number and also p plus q minus 2 by 2 is negative integer, then we put cot x as t or tan x as t as required, as per requirement. Okay. Now, second form, if your integral is of the form integration of dx by a plus b cos square x or dx by a plus b sin square x, or another form dx by a sin square x plus b cos square x, or dx by a sin x plus b cos x whole square, or dx by a plus b sin square x plus c cos square x, then to integrate such form, how we integrate? First, divide both numerator and denominator by cos square x. First step. Then replace sec square x by 1 plus tan square x in the denominator. So when we divide numerator denominator, there is a term involving sec square x. Then we if there is any sec square x, then we replace that sec square x by 1 plus tan square x. And after replacing sec square x by 1 plus tan square x, put tan x as t. So what is substitution here? Tan x as t. So when we substitute tan x as t, so when you differentiate it, we get sec square x dx is equal to dt. So by following this three step, we can find the integral of such form. That's this five forms. Okay. Now, if your integral is of the form integral of a sin x plus b cos x by c sin x plus d cos x dx. Okay. Now, to integrate this, we use this method. We try to write the numerator part a sin x plus b cos x as a time differentiation of denominator plus b into denominator, that is a into d by dx c sin x plus d cos x plus b into c sin x plus d cos x. Okay, where this value a and b can be found by equating the coefficient of sin x and cos x or both sides. Okay. Now, to evaluate the integral of the form integral of 1 by a sin x plus b cos x dx, or integral of 1 by a plus b sin x dx, or integral of 1 by a plus b cos x dx, or of the form 1 by a sin x plus b cos x plus c dx. So integrate such form. First, put sin x is equal to 2 tan x by 2 by 1 plus tan square x by 2, and cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. These are the specific form. To integrate this form, we follow this step. Okay. Then replace 1 plus tan square x by 2 by sec square by 2, and as a substitution, substitute tan x by 2 as t. Okay. So by follow this two step, we can integrate integral of these four forms. Now next form is to evaluate the integral of the form integral of a sin x plus b cos x plus c by p sin x plus q cos x plus r dx. We use the method write this numerator part a sin x plus b cos x plus c as a time differentiation of denominator part, that is d by dx p sin x plus q cos x plus r, plus b into denominator part p sin x plus q cos x plus r plus c. Now simplify this, and when you simplify, just equating the coefficient, you get the, when we equate the coefficient of sin x, cos x and constant term, we get the value of a, b and c. And when we get the value of a, b and c, substitute into the form and then integrate. You can integrate the integral. Okay. Next, we will weight the integral of the form integration of x square plus 1 by x the power 4 plus kx square plus 1 dx, or integration of x square minus 1 by x the power 4 plus kx square plus 1 dx. So if your given integral is in this two form, then what we do? First, divide numerator and denominator by x square. Okay, and make a perfect square in the denominator. First thing, divide numerator and numerator by x square and then make a perfect square in the denominator as x plus minus 1 by x whole square, and then put x plus 1 by x or x minus 1 by x as t as required, as per your requirement. Okay. So how to find this integral? First, divide numerator and numerator by x square, then make the perfect square in the denominator, and then as x plus minus 1 by x whole square, and then put as per requirement either x plus 1 by x as t or x minus x by t. Okay. Now, substitution for some irrational integrand. Okay. So if your given integral has expression like root under a minus x by a plus x or root under a plus x by a minus x, then use the substitution x is equal to a cos 2 theta. Okay. And if it like root under x by a plus x, comma root under a plus x by x, root under x into a plus x, or 1 by root under x into a plus x, then use the substitution x is equal to a tan square theta or x is equal to a cot square theta. Third, if it is of the form root under x by a minus x or root under a minus x by x or root under x into a minus x or like 1 by root under x into a minus x, then use the substitution x is equal to a sin square theta or x is equal to a cos square theta. Function like root under x by x minus a, these all are irrational integrand, and like x minus root under x minus a by x, root under x into x minus a, or 1 by root under x into x minus a, then we use substitution x is equal to a sec square theta and just apply the substitution method to resolve this integral. For integral like integral of dx by x minus alpha beta minus x and integral of root under x minus alpha by beta minus x dx, or integral of root under x minus alpha into beta minus x dx, just use the substitution x is equal to a alpha cos square theta plus beta sin square theta. Now, like integral of dx by px plus q into root under ax plus b, use the substitution ax plus b is equal to t square. Clear? For integral of the type dx by ax square plus bx plus c root under px plus p, use the substitution px plus q is equal to t square. We have to remember all this substitution for each special type of this irrational integrand. Okay, then we can easily find out the value of integral when such type of integrand term involving on the integral. Now, for integral of dx by px plus q root under ax square plus bx plus c, we use a substitution px plus q is equal to 1 by t, and for integral of dx by px square plus q root under ax square plus b, first substitute x is equal to 1 by t and then After substitution, we use a plus bt square as z square as your new substitution, second substitution. Okay. Now, next method of integration, integration by parts. Let's suppose we have two functions u and v and both are function of x. Then integration of u into v dx is equal to u into integration of v dx minus integration of differentiation of du by dx, that is differentiation of u du by dx into integration of v dx dx. Okay. So just carefully observe this formula here. If we take u as first function, v as second function, then on the formula, we differentiate the function u, we differentiate the first function and integrate the second function, that is u into integration of v dx minus integration of differentiation of u, that is du by dx into integration of v dx. Okay. So when we have two function and product of two function and we have to integrate them, so first thing, in by parts, the first step is we have to choose which function we want to take it as u and which function we want to take it as second function v according to the formula, because in the formula we differentiate u and we integrate v. So we choose v in such a manner for that we know that its integration, or comparatively the function u, the integration is easier. So there is a rule that is called elate rule. And what is the full form of elate? Elate for inverse function, L for logarithmic function, A for algebraic function, T for trigonometric function, E for exponential function. And what this elate represent? So according to the order of this elate, it represent the difficulty level of integration. For inverse function, the integration of inverse function is comparatively difficult than logarithmic, algebraic, trigonometric, and exponential. In the same way, for logarithmic function, the integration is easier than inverse function, but it is difficult than algebraic, trigonometric, and exponential. For exponential function, its integration is easier comparing to all these four: inverse, logarithmic, algebraic, and trigonometric. So it just represent the order of difficulty of integration. Okay. So if one of the function is not directly integrable, then we just take it as a first function. Okay. If you have two function and one of them is not directly integrable, then we take that function as first function, because in the formula we just differentiate the first function. Okay. And if both the function directly integrable, if there are two function, product of two function, and we can integrate both the function, then the first function is chosen in such a way that its derivative vanishes easily, or the function obtained the integral sign is easily integrable. Okay. Easily integrable, and that can be chosen by this elate. Next, if only one which is not directly integrable, if there is a function and we want to integrate that and we don't know its integration, like a function log x, then in such case we can write log x as log x into 1, and we take that one as the second function and log x as first function, and that's how we can find the integral of log x dx by using by parts method. So what is the formula by parts? Integration of ub dx is equal to u into integration of v dx minus integration of du by dx into integration of v dx dx. Okay. Important thing in by parts, the first thing is we have to choose u and v, which function we want to take in as first function and which function we want to take it as second function. Okay. Now, some special integral based on integration by parts. We use integration by parts to find this formula. First one, integration of ex fx plus f dash x dx is equal to fx into ex plus c. Very important formula that whenever we have to integrate, and it is of the quotient integrand is of the form ex into fx plus f dash x, or if we reduce into in this form, then we can directly find its integral, that is equal to fx time ex plus c. Integration of e to the power ax sine bx plus c dx is equal to e the power ax by a square plus b square integral of a sine bx plus c minus b cos bx plus c plus k. And third, integration of e the power ax cos bx plus c dx is equal to e the power ax by a square plus b square into a cos bx plus c plus b sine bx plus c plus k. Okay. Here c and k are integral constant. Now next method is integration by partial fraction. If your integrand is of the form integral of px by qx dx, where px and qx are polynomial in x with degree of px, then its partial fraction depend upon the nature of qx. So according to the nature of factor of qx, you use the different form of partial fraction. If your qx is the type x minus a1 into x minus a2 into x minus a3 dot dot x minus an. So if your integral is of the form px by qx, where both are polynomial, and we can factorize the term q polynomial qx as this linear factor, product of linear factor, like x minus a1 into x minus a2 into x minus a3 dot 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 x minus an. Then we can write px by qx is equal to a1 by x minus a1 plus a2 by x minus a2 plus a3 by x minus a3 plus dot 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 plus an by x minus an, and then we find the value of a1, a2, a3, and an, and we can and then we integrate by using the standard formula. Okay. So just wait for a moment. Now we'll practice some question based on indefinite integral. Okay. So let's solve some question based on indefinite integral. Okay. Question number 1. If integral of dx by x plus x the power 7 is equal to px, then what is the value of integral x the power 6 by x plus x the power 7 dx? Options are option A log mod x minus px plus c, option B log mod x plus px plus c, option C x minus px plus c, and option D x plus px plus c. Okay. So to solve this question, here what is given? Integral of dx by x plus x the power 7 is equal to px. So, and also in the option there is a term involving px. So we have to use this to solve integral of x the power 6 by x plus x the power 6 dx. So that's how we can, by using the algebraic manipulation, we can write this integral in terms of integral of, so that we can use integral of dx by x plus x the power 7 dx is equal to px. Okay. So just think that and try to solve this. Okay. Mark your option. One simple hint, we can write the denominator part x plus x to the power 7 as x into 1 plus x to the power 6. Then manipulate the numerator part so that you get dx by x plus x to the power 7, where you can use directly px. Okay, let's solve. So correct answer is option A, log mod x minus px plus c. Let's solve. So let's suppose I is equal to integral of x to the power 6 by x plus x to the power 7 dx. Okay, so we can write the denominator part x plus x to the power 7 as x into 1 plus x to the power 6. Okay, and then we can manipulate the numerator part, just add 1 and subtract 1 in the numerator. We get integration of 1 plus x to the power 6 minus 1 by x into 1 plus x to the power 6 dx. That is equal to I is equal to integration of dx by x minus integration of dx by x plus x to the power 7. Now this is the second term, and this term is equal to integration of dx by x plus x to the power 7, and its integration is equal to px. So here we can directly use px. And what about the first term, that is integration of dx by x? We already know the formula for this integral, and that is equal to log mod x. So I is equal to log mod x minus px plus c, and this is the value of integral x to the power 6 by x plus x to the power 7. So correct answer is option A. Okay, got it? Clear? Okay, next question. Now we want to integrate x cube minus 1 by x to the power 4 plus 1 into x plus 1 dx, and is equal to, given options are option A 1 by 4 log into 1 by 4 log 1 plus x to the power 4 plus 1 by 3 into log 1 plus x cube plus c. Option B 1 by 4 log 1 plus x to the power 4 minus 1 by 3 log 1 plus x cube plus c. Option C 1 by 4 log 1 plus x to the power 4 minus log 1 plus x plus c. And option D 1 by 4 log 1 plus x4 x to the power 4 plus log 1 plus x plus c. Okay, so let's solve. Correct answer is option C, that is 1 by 4 log 1 plus x to the power 4 minus log 1 plus x plus c. Let's solve. Let I is equal to this integral of x cube minus 1 by x to the power 4 plus 1 into x plus 1 dx. So we just add x to the power 4 and subtract x to the power 4 on the numerator part. We get x cube plus x to the power 4 minus x to the power 4 minus 1 by x to the power 4 plus 1 into x plus 1 dx. Okay. From here we get, just take x cube common from first two part, we get x cube into x plus 1 minus x to the power 4 plus 1 by x to the power 4 plus 1 into x plus 1 dx. Okay. So from here we get x cube by x to the power 4 plus 1 integration of x cube by x to the power 4 plus 1 dx. We just distribute the integral over the subtraction. We get and minus integration of 1 by x plus 1 dx. Okay. Now to integrate first term, as we use the substitution method, we take x to the power 4 plus 1 as a new variable and we differentiate it. Like if you take as t, then its differentiation is 4 into x cube dx is equal to dt. So in place of x cube dx, we can write dt by 4 and we get integration of 1 by 4 dt by t and apply the formula. So you get 1 by 4 log t and substitute back the value of t. So we get 1 by 4 log x to the power 4 plus 1 and integration of 1 by x plus 1 is minus log x plus 1 plus c. Okay, simple. Now question number 3. Integrate x plus 1 into x plus 2 the power 7 into x plus 3 dx. Options are option A x plus 2 the power 10 by 10 minus x plus 2 the power 8 by 8 plus c. Option B x plus 1 the power 2 by 2 minus x plus 2 the power 8 by 8 minus x plus 3 the power 2 by 2 plus c. Option C x plus 2 whole power 10 by 10 plus c. And option D x plus 1 power 2 by 2 x plus 2 the power 8 by 8 and plus x plus 3 the power 2 by 2 plus c. Okay, so you have to find this integral. Here the terms are x plus 1 x plus 2 the power 7 into x plus 3 by dx. So if you want to simply integrate this, then we have to find x plus 2 the power 7. Okay, we have to open it and then by using multiplication we break it into individual term and then we can easily integrate. But can we simplify this integrand into a similar integral where we can directly integrate? Okay, so what is the appropriate substitution for this integral? Just think and simplify. Okay, take a hint. Substitute x plus 2 as new variable. Okay, let's solve. Correct answer is option A x plus 2 the power 10 by 10 minus x plus 2 the power 8 by 8 plus c. Okay, so consider I is equal to integration of x plus 1 into x plus 2 the power 7 into x plus 3 dx. So put x plus 2 is equal to t. We take x plus 2 as a new variable. So we can write x is equal to t minus 2 and when we differentiate we get dx is equal to dt. That is I is equal to integral of t minus 1 into t the power 7 into t plus 1 dt, and from here we can write t minus 1 into t plus 1 as t square minus 1. So we get integration of t square minus 1 into t to the power 7 dt. That is equal to integration of t to the power 9 minus t to the power 7 dt. And when we integrate it, we get t to the power 10 by 10 minus t to the power 8 by 8 plus c. Because you apply the power rule, as integration of xn is equal to x to the power n plus 1 by n plus 1. So integration of t to the power n is t to the power n plus, 9 plus 1, that is 10. That's you get t to the power 10 by 10 minus 10 to the power t to the power 8 by 8 plus c. Okay, now substitute back the value of t, that is x plus 2. So we get x plus 2 to the power 10 by 10 minus x plus 2 to the power 8 by 8 plus c. So correct option is option number A. Clear? Any doubt? Next question, question number 4. Now, the integration of dx by x square into x to the power 4 plus 1 whole power 3 by 4 equals. Options are option A, x to the power 4 plus 1 by x to the power 4 plus c. Option B, x to the power 4 plus 1 by whole power 1 by 4 plus c. Option C, minus x to the power 4 plus 1 by 1 by 4 plus c. D, minus x to the power 4 plus 1 by x to the power 4 by 1 by 4 plus c. Okay, so we also solve this by substitution method. So just find out what is the appropriate substitution and solve. Okay, so try. As I hint, take x to the power 4 common from the denominator part. Let's solve together. So correct answer is option D, minus x to the power 4 plus 1 by x to the power 4 whole power 1 by 4 plus c. So I is equal to, consider I is equal to integral of dx by x square into x to the power 4 plus 1 whole power 3 by 4 is equal to integral of dx by x5 x to the power 5 into 1 plus x the 1 by x to the power 4 whole power 3 by 4. We just take x to the power 4 common, so we get x to the power 4 the power 3 by 4, 4 cancel out, so x cube is common. So dx by x square into x cube, x to the power 5 into 1 plus 1 by x to the power 4 whole power 3 by 4. So now put 1 plus 1 by x to the power 4 is equal to t to the power 4. So when we substitute, we differentiate it with respect to x, we get minus 4 the power minus 4 by x5 x to the power 5 dx is equal to 4 t cube dt. Clear? As differentiation of 1 by x to the power 4 is differentiation of x to the power minus 4, and that is equal to minus 4 by x to the power 5 dx, and differentiation of t to the power 4 is 4 into t cube dt. So from here we get dx by x to the power 5 is equal to minus t cube dt. So now my integral become, in place of dx by x to the power 5, we substitute minus t cube dt, and for 1 plus 1 by x to the power 4, we substitute t to the power 4. So we get t to the power 4 the power 3 by 4, that is equal to t cube. So t cube cancel out, we get minus integral of dt, that is minus t plus c. Now substitute back the value of t, and that is minus 1 plus 1 by x to the power 4 by whole power 1 by 4 plus c, and that is minus x to the power 4 plus 1 by x to the power 4 whole power 1 by 4 plus c. Okay. Now question number 5. If integral of sine x by sine x minus alpha dx is equal to ax plus b log sine x minus alpha plus c, then the value of a comma b is, options are sine alpha comma cos alpha, sine alpha, minus sine alpha and cos alpha, minus cos alpha, sine alpha. Okay. So try to find the integral of 1 by sine x by sine x minus alpha, and when you get that, we compare and find the value of a and b. Okay. So try. Let's solve. Correct option is option B, cos alpha and sine alpha. So consider I is equal to integral of sine x by sine x minus alpha dx. So we use the substitution method and substitute x minus alpha as t, and when we differentiate it, we get dx is equal to dt. So I is equal to integral of, in place of x we write t plus alpha, that is x equal to t plus alpha, we get sine t plus alpha by sine t dt. Now we use the trigonometric entity formula of sine t plus alpha, that is equal to sine t into cos alpha plus sine alpha into cos t. So when we use that formula, we get integration of sine t cos alpha by sine t dt. Sine t cancel out. We get integration of cos alpha dt plus integration of sine alpha into cos t by sine t dt. So integration of cos alpha is constant term, so it come out from the sign of integration, we get integration dt, that is t. So cos alpha into t plus, now sine alpha is constant term, so we get plus sine alpha into integration of cos t by sine t dt, and that is log sine t plus c. Okay. Now we substitute back the value of t. So t is equal to x minus alpha. So when we substitute, we get cos alpha x minus alpha plus sine alpha log sine x minus alpha plus c. Okay. And now as alpha, cos alpha is constant term, so you only left x cos alpha plus sine alpha log sine x minus alpha plus c. And when we compare with ax plus b log sine x minus alpha plus c, we get a is equal to cos alpha, the coefficient of x, and b is equal to sine alpha, coefficient of log sine x minus alpha. Okay, clear? Next question. If integration of fx by log sin x dx is equal to log sin x plus c, then fx is equal to, options are sin x, option B cos x, option C log sin x, and option D cot x. Okay, so let's solve. Correct answer is option D, that is cot x. So we have integration of fx log sin x is equal to log log sin x plus c. So we can relate this with a standard formula, that is when we integrate integral of g dash x by gx dx, that is equal to log gx plus c. Okay, so when we compare this with formula, we get fx is equal to g dash x, that is d by dx log sin x. Okay, because gx is log sin x, and on the numerator part there is g dash x, so differentiation of gx is equal to fx, so fx is equal to d by dx log sin x, and we have to find the value of fx. So differentiation of log sin x is cot x. As differentiation of log sin x, we use the chain rule. So log sin x 1 by sin x, and then differentiation of sin x, that is cos x. So cos x by sin x, that is cot x. So the value of function fx is equal to cot x. That is your correct answer. Okay, clear? So in this question, we just use this standard formula that whenever we have to integrate integration of j dash x gx dx, the answer is always log gx plus c. Okay. So in today class, we covered indefinite integral. It's formula related to indefinite integral, different types of form, what kind of substitution you use to for solve different kind of integral, and we also practice some question. Okay. So I hope the lesson was helpful. Okay. Thank you. Hello students, in today's lecture we are going to learn about heat transfer. Okay, and this is theory part. This is our disclaimer. So let's see the trend analysis in JEE main examination. So if we talk about the overall weightage according to last 5 years, so we can say 2.08%. Okay, and if we talk about yearly question distribution, so we can say in 2023 question asks from measurement of temperature, number of questions 1, and if we talk about their difficulty level, so we can say question was average. Okay, similarly in 2022 question asked from thermal expansion, number of questions 1, and if we talk about their difficulty level, so we can say question was average. In 2021 question again asked from thermal expansion, number of questions 1, and the difficulty level average. In 2020 question asked from thermal expansion, number of questions 1, and if we talk about the difficulty level, so we can say question was easy. Okay, so these are the important concepts for the exam. In today's lecture we will cover first conduction, then we will learn thermal conductivity, after that thermal resistance, then combination of metallic rods like series combination, parallel combination. All right, then we will discuss convection, after that we will see natural convection and forced convection. All right, then we will learn radiation, then we will discuss about interaction of radiation with matter, then some common terms and points. All right, then we will discuss perfectly black body. All right, then we will discuss Stephen's law, then we will discuss black body spectrum, and last we will see Wien's displacement law. Okay, so these are the concepts which we will discuss in today's lecture one by one. So are you ready? So heat transfer, think about it. Basically students, heat transfer means the transfer of energy from one part to another part. Okay, uh, there can be different transfers methods for this, among which the first is conduction. Okay, so we can say conduction is the process by which heat energy is transmitted through a collisions between neighboring atoms or molecules of a material, meaning that conduction is a process in which heat energy is transferred when collisions occurs between neighboring atoms and molecules. Okay, now if we talk about an example. Okay, suppose you have a rod. Okay, like this, you have a rod, and you are heating one end of that rod as shown in the figure. Okay, then what happens? After some time the heat starts reaching your hand. It means from here to here. Okay, why? Why heat starts reaching your hand? Because when this portion is heated, when this portion is heated, the particles here start vibrating. Okay, due to vibration, energy generated, and the particles that were vibrating by colliding with their neighboring particles made them vibrate too, meaning the particles in this area vibrated, and by colliding with their next particles they transferred energy. Okay, so we can say the first particle is directly taking energy from the flame and vibrating. Now the second particle is taking energy from the first particle. Clear? Similarly, there will be many particles in this rod. Okay, so due to their vibrations, this energy, that is heat energy, is transferred. All right. So this is the phenomena of conduction. One more important point is that uh, conduction is fastest in solids. Then it occurs in liquids. And if we talk about gases, the process of conduction in gases is very low, almost negligible. All right. Because in solids, particles are closely packed. So when one particles vibrates, it collides with next particle and transfers energy. Clear? In liquids, particles are somewhat close, but they are bit further apart compared to solids. Still, energy transfer can occur. Okay, so conduction is lowest in gases and conduction is highest in solids. Okay, everyone. And the reason for this is that in solids, particles are very close to each other. In gases, particles are quite far from each other. All right, clear, everyone? The next topic is thermal conductivity. We will discuss thermal conductivity through a solid. So consider here a solid material as shown in the figure. Okay, having cross sectional area A and length L. It also has a finite temperature difference between two ends. All right. So first temperature let T1 and second one is T2. Clear? So that temperature difference is delta T. So the total heat transfer from one end to another end will be proportional to the cross sectional area A and the temperature difference delta T, and inversely proportional to the length L and time T. Okay. So the formula for the heat transfer will be Q equal to Ka into delta T into T divided by L, where A is equal to area of cross section, delta T temperature difference T2 minus T1, small t time elapsed, and capital K is thermal conductivity, and L is length of conductor, or we can say thickness. All right. Now the rate of
transmission of heat by conduction, we can calculate uh, H is equal to delta Q upon delta T. And we know the value of delta Q, that is K into A into delta T into T divided by L. So just substitute the value of delta Q in this relation and rearrange the formula. You will be get H is equal to Ka into delta T divided by L. Alright. And if we talk about the unit, so we can say the unit of thermal conductivity is watt per meter per Kelvin. Alright. The next topic is thermal resistance. We can relate thermal resistance to electrical resistance in electricity. So if you study by comparing a little, you will understand it easily. First, just as there is a charge, okay, so here we can say there is a amount of heat. Just as there is a current, here is the rate of heat flow. Now just there is a resistance here, exactly so there is a here is a thermal resistance. Okay. So look, our H is equal to delta Q equal to uh, here delta Q divided by delta T. If we take its magnitude, then the same thing can be written as capital K into A into delta T divided by L. We are just modifying it a little, so it will be uh, delta T divided by L divided by Ka. Okay. So the term L by Ka is the term is called thermal resistance. Okay. Now if you are compare with Ohm's law, which is potential difference equals to V equal to IR, then here delta T will act as potential difference and heat rate will act as current, meaning that the thermal resistance is opposition to the flow of heat, and electrical resistance is the opposition of flow of electric current. Okay, so you have to remember this formula for thermal resistance. So now this equation of our at the very top, can we write it as H is equal to delta Q divided by delta T, okay, which is equal to delta T divided by R thermal. So this formula for heat transfer rate is equivalent to Ohm's law, which is I equal to delta V divided by R electrical. So if we compare these two formulas, it will be known that heat rate is equivalent to current, because heat rate is the rate of flow of heat and electric current is the rate of flow of charges. Clear? And if we talk about the temperature, so we can say temperature difference is equivalent to potential difference, and R thermal is equivalent to R electrical. Alright. So with the help of this analogy, you can remember both these formulas. Alright everyone. Next, the next topic is combination of two metal rods. Just like in electricity, the concept of series and parallel combination of resistors comes. Okay. Similarly, here comes the series and parallel combination of metallic rods. So let's start with the series combination of metallic rods. So look at here in the figure, we have a metallic rod and both are connected in series combination. Series combination means end to end connection. Okay. So in series combination, the heat flow rate through both rods of both rods of both rods will be same. Okay, so we can say there is a two rod as shown in the figure. First having length L1, second having length L2. But the amount of flow of heat from these metallic rods is same. Okay, because the rod is end to end connected. So in series combination, we need to find the equivalent thermal conductivity for the series combination. All right. So in this case, when both rods have the same cross sectional area and lengths are L1 and L2. Okay. So the formula for equivalent thermal conductivity will be Ks equal to L1 plus L2 divided by L1 divided by K1 plus L2 divided by K2. Now the important point here is this: K1 and K2 are the thermal conductivities of each rod respectively. Okay, so if the lengths are the same, then this formula will further simplify to Ks is equal to 2K1 K2 divided by K1 plus K2. Now remember this point, this formula is valid only for if L1 equal to L2. Okay. Here we can also find the temperature of the interface, or we can say junction. If this junction temperature is T, then its formula will be T equal to K1 T1 plus K2 T2 divided by K1 plus K2. Alright. The next combination of the metallic rods is parallel combinations of metallic rods. Okay. So as shown in the figure here, uh, we have a two rods. First having cross section area A1, second having cross section area A2. Okay. The important point here is this: both rods are parallelly connected. Okay. So a parallel combination of rods occurs when the rods are joined side by side with their ends connected together as shown in the figure. So we can say in a parallel combination of rods, the temperature at their ends will be the same. Okay. Therefore, when combined in this parallel configuration, the formula for the equivalent thermal conductivity will be Kp equal to K1 A1 plus K2 A2 divided by A1 plus A2. And if the series, if the areas are equal, okay, it means A1 equal to A2. If the areas are equal, it further simplifies to Kp equal to K1 plus K2 divided by 2. Okay. So these formulas are very important for the exam, for the series combination and for the metallic combinations, for the parallel combination of the metallic rods. Okay everyone. Next we discuss the second method of heat transfer, and which is convection. All right. So in fluids, heat transfer predominantly occurs through convection. So what is convection? Convection is a mode of heat transfer in which heat transfer in fluids in which particles of the fluid move by themselves and transfer energy from one part to another part of the fluid. Okay. So listen carefully everyone. Observe the figure. Observe the figure. the particles at the bottom of the beaker here, okay, uh, quickly absorb more energy from the flame compared to other particles such as those at the top. Yes or no? So we can say these energized particles then move bottom towards the from the bottom towards the top, okay, and thus heat is carried away by the molecules themselves. So this is the phenomena of convection. Convection is of two types. First, natural convection, okay, in which particles naturally move from one part of the fluid to another part. Second is forced convection, in which these high energy particles are made to move from one part to another by an external agency. Okay, so we will learn both type of convection, natural convection and forced convection. Clear? So in natural convection, gravity plays an important role when a fluid is heated. So in that case, it expands and becomes less dense. Therefore, gravity lifts it upwards. Okay. So we can say then cooler, uh, d- uh, denser fluid sinks to down to take the place of the warm fluid, creating a continuous cycle of heat transfer through the fluid's motion. Okay. So suppose you have a hot egg, okay, and you want it to be cooled. Clear? So the one way is to leave that hot egg in the room. Then uh, what will happen is that this hot egg will give heat to the particles near it, due to which the air particles will rise upwards and a region of lower density will be created here. Okay, so due to which other cold particles will come here, and then they will also take heat and move forward. Then others will come and they will also take heat and move forward, and in this way the egg will gradually cool down. So in this process, air flow is created automatically and the egg cools down. So this is part of natural convection. But now question is, what is forced convection? Okay, so if we talk about the forced convection, so we can say, suppose this hot egg is placed like this. Look at here, like this. If we place a fan near it, okay, then due to that the particles that come on to it will collide and they will take heat from it and move forward with the heat. Okay, so we are doing here is that the flow of rate of particles or air has increased, and due to which particles will come quickly, take heat and move forward. Okay, earlier what was happening was the particles that were present there were taking heat slowly and moving upwards. Then other particles were coming and this process was continuing like that. So for this reason, when we sit down to eat food at home and hot hot food is placed in front, we blow on it. Okay, so due to this it comes under forced convection, and if you leave it as it is, then things will cool down anyway, but it will take time. Okay, so to cool quickly we use forced convection. Okay, so in natural convection gravity plays an important role. When any fluid heats up, it warms parts, expand, and its density decreases, due to which it rises upwards. So this is the two types of convection: natural convection and forced convection. All right, everyone. Next, the third mode of heat transfer is radiation. So if we talk about the radiation, we can say the process of heat transfers occurs between two bodies through electromagnetic radiation. Okay, here it makes no difference whether there is any medium between the source and the destination of the heat, because in radiation energy is transferred by electromagnetic waves, and electromagnetic waves can also travel in a vacuum. Clear? So as you can see in the figure here, your hands get warm because heat is being carried away from the flame to your hands by thermal radiation. Clear? The next topic is interaction of radiation with matter. Alright. So the interaction of radiation with matter means how radiation interacts with matter. So when Q amount of heat is incident on a body, then some heat is absorbed by it and some heat is reflected and some is transmitted through it. Okay, so here we consider the when radiant energy Q is incident on body and a part of it QA is absorbed, another part QR is reflected back, and at another part QT is transmitted. Okay, such that Q equal to QA plus QR plus QT. Okay, or we can say QA upon Q plus QR upon Q plus QT upon Q equal to 1, or we can say A plus R plus T equal to 1, where A equal to QA upon Q, absorbing power, or we can say absorptance. Similarly, R equal to QR upon Q equal to reflecting power or reflectance, and T equal to QT upon Q, transmitting power or transmittance. Alright, now some common terms and points. We will discuss some common terms or points that are used here. First, let's talk about absorptive power. It is defined as the ratio of radiant energy absorbed by the body a given time to the total radiant energy incident on it due to during the same time interval. Okay, and it can be denoted by A. All right, everyone, clear? So mathematically we can write A equal to energy absorbed divided by energy incident. If we talk about a perfectly black body, so we can say a perfectly black body absorbs all radiations incident on it, and the absorbed absorptive power of a perfectly black body is maximum and unity. Next comes spectral absorptive power. Think about it. So we can say spectral absorptive power means that out of energy incident at a particular wavelength, how much energy is absorbed here. So when we take their ratio, we get spectral absorptive power, that is for a particular wavelength. Until now we discussed the total. For instance, if there is an object, radiation is incident on it. Okay, so suppose radiation from 400 nanometers to 700 nanometers is falling. All right, so the total energy incident, we wrote it in the form of a fraction energy absorbed divided by energy incident. Clear? So in this way we obtained absorptive power. But if instead of this entire range we talk about a particular wavelength, suppose we name it that a wavelength of 601 nanometers to is incident, then how much energy is coming and what fraction of that particular wavelength has been absorbed. So when we start taking the ratio for a particular wavelength, we define it as a lambda. Okay, and when we get the value of a lambda, it will be different for 601, different for 602, and different for 603. Similarly, if the wavelength decreases, there will be different values for 500, 400, and all others. So from here, uh, we can say here to here, that is 0 to infinity. Okay, when we integrate the entire wavelength range, we obtain total absorptive power. Okay, so we can understand it mathematically. So A equal to integration 0 to lambda 0 to infinity a lambda d lambda. Okay, a lambda is the spectral absorptive power for a particular wavelength, and when we integrate the spectral absorptive power for all wavelengths from 0 to infinity, we obtain total absorptive power. All right, next comes our emissive power, denoted by E. So emissive power means that the total energy radiated by a body per second per unit area. All right, so mathematically E equal to 1 upon A into delta Q upon delta T. Next, we have spectral emissive power E lambda. So just as we saw spectral absorptive power, similarly there is an emissive power. So how much a body radiates at a particular wavelength is its emissive power for that wavelength lambda. So the total emissive power can be found by integrating with its help. So E equal to lambda integration 0 to infinity E lambda d lambda. Then comes emissivity epsilon. Now how do we define emissivity? We just discussed emissive power. So now comes the emissivity of a body at a given temperature. It is defined as the ratio of the total emissive power of the body to the total emissive power of a perfect black body at that temperature. Okay, all right, clear? Any doubt here? Mathematically, epsilon is equal to E upon capital E. Alright. Next is perfectly black body. Okay. Uh, since I have mentioned the term black body multiple times. Okay. So let's understand what a perfect black body is. So we can say a perfectly black body is one that completely absorbs radiations of every wavelength incident on it. As we explained earlier, whenever radiation is incident on a body, that body reflects some of the radiation, transmits some, and absorbs some. Therefore, a perfect black body means a body in which when radiation falls on it, the entire radiation is absorbed. Okay. So look at the figure. This type of configuration. Here, look at here. So where we have a sphere with a small hole, this one, and an internal shape such that if something enters, it will keeping moving inside, reflecting, and will not exit. Then its entire setup can be considered a perfectly black body. Okay, and theoretically, this is a perfectly black body. All right. Thus, absorbing power of a perfectly black body is 1. Now, when a perfectly black body is heated to a suitable temperature, uh, the process is slightly different. A black body at some temperature T also emits radiation for all wavelengths, meaning it will emit not just a particular wavelength but every possible wavelength. So the sun's temperature is very high, approximately around 6000 Kelvin. Okay, and the sun emits all possible radiations. All right. So sun has temperature 6000 Kelvin. So we can say when we can consider the sun as a black body that emits all wavelengths. For perfectly black body, A equal to 1 and R equal to T equal to 0. And for a perfect reflector, A equal to T equal to 0 and R equal to 1. And for a perfect transmitter, T equal to 1 and A and R equal to 0. Okay. Now comes Stephen's law. Stephen's law is very important. All right, everyone. So according to Stephen's law, if there is a body with temperature T, then we can observe how much heat or radiation will be emitted from that body. Okay. So according to Stephen's law, the intensity of radiation emitted by a black body, which is the energy per unit time per unit area, is directly proportional to the fourth power of the temperature of the black body. All right. So mathematically we can write I is directly proportional to fourth power of temperature. So for removing the proportionality sign, there is a constant, that is sigma here. So we can write it as I equal to sigma into T raised to the power 4. Also, if there is a surrounding temperature T naught, then I equal to sigma into T raised to the power 4 minus T naught raised to the power 4. Okay, where sigma is a constant known as the Stefan's constant, and its value is 5.67 into 10 raised to the power minus 8 watt per meter square and Kelvin raised to the power minus 4. Okay, now if the body is not a black body, in that case radiation absorbed or emitted will be less than the black body. Okay, so let the body has emissivity epsilon. Stephen Boltzmann modified as I equal to epsilon sigma into T raised to the power 4. Okay, everyone, clear? If yes, write in the chat box. So the total radiant energy Q emitted by a body of surface area A in time t is given by Q equal to A into T into I, which is equal to A T epsilon sigma into T raised to the power 4. Now discussing radiant power, or we can say Stephen's law. So radiant power, this is the energy emitted by a body per unit time. So P equal to Q divided by T, which is equal to A into epsilon into sigma into T raised to the power 4. So if a black body, or we can say if a body at temperature T, it's surrounded by another body at temperature T naught, where T naught is less than T, then according to Stephen's law, its power will be P equal to epsilon into sigma into A into T raised to the power 4 minus T naught raised to the power 4. Okay. Black body spectrum. So let's now look at the black body spectrum. This refers to the spectrum of radiation emitted by a black body as shown in the figure here. Okay, this figure. Energy and on and E lambda upon lambda on horizontal axis. It is a continuous spectrum, which means that it contains all wavelengths, but the intensity varies for different wavelengths, meaning some radiation is present in a smaller amount while other are in larger amount. Okay, also at a given temperature, initially the intensity of thermal radiation increases with an increase in wavelength and reaches a maximum value at a particular wavelength lambda. Okay, so as we see here, look at here in the figure, T2 is greater than T1, T3 is greater than T2, and T4 is greater than T3. All right, yes or no? So how from this graph we can say as the temperature increases, okay, the maximum value of lambda m is shifts towards the left. Yes or no? So on increasing the wavelength beyond lambda m, the intensity of radiation E lambda starts decreasing. Okay, from this spectrum we get a few points. Let's see. The first point, we can say the total area under E lambda versus lambda curve gives the total intensity of radiation at that temperature. All right, so this is the first. This curve is in accordance with Stephen's law of radiation, means the area from which intensity can be found is found to be proportional to the fourth power of the temperature. All right. Next is Wien's displacement law. So we can say according to Wien's law, the product of wavelength corresponding to maximum intensity of radiation and temperature of body is constant. So lambda m into T is equal to constant, that is equal to B. Now here B is known as Wien's constant and its value is 2.8189 into 10 raised to the power minus 3 mk. Okay, so this is the numerical value or constant value of the Wien's constant. Okay everyone. Thank you. Now we will solve some practice questions. Thank you for your attention. So are you ready for the practice questions? Yes or no? Tell me. Hello students. Now we will solve some practice questions based on heat transfer. This is our disclaimer. Now we will solve some practice questions based on heat transfer. Okay. So this is our first question. A cylindrical rod is having temperatures T1 and T2 at its end. The rate of flow of heat is Q1 calorie per second. If all the linear dimensions are doubled, keeping the temperature constant, then rate of flow of heat Q2 will be what? Okay. So in this question asks about the what is the new rate of heat flow? Q2 is what? Okay. So there is a four options. Option A 4Q1, option B 2Q1, option C Q1 upon 4 and option D Q1 upon 2. So which option is correct? And please try to solve this question and tell me the correct option. Everyone. Please solve this question, everyone. Which one is correct? So the correct option is option B. Okay, let's see the solution. So the rate of heat flow is directly proportional to the cross sectional area and the temperature difference between the two ends. Okay, and inversely proportional to the length. So this is our formula. All right. So according to question, cylindrical rod, we have a cylindrical rod and the temperature T1 and T2 at its ends. Look at here, T1 and T2. Okay, and the rate of flow of heat is Q1 calorie per second. So initially Q1 is equal to uh, Ka1 into T1 minus T2 divided by L1. Okay, but on doubling all dimensions, it means L2 equal to 2 times of L1. Okay, length and radius has been doubled. So here area will become 4 times because the length and radius uh, has been doubled. Okay, so A2 is equal to 4 times of A1. All right. Now because the rate of heat flow is directly proportional to cross sectional area and inversely proportional to length, so the new heat flow will be Q2 is equal to K into A2 into T1 minus T2 divided by L2. Okay, so just put the values in Q2. So we know Q2 equal to K into A2. So A2 is what? A2 is 4 times of A1. Okay, T1 minus T2 divided by L2. L2 is what? L2 is 2 times of L1. Alright. So when we rearrange the terms, you will be get 2 into K into A1 into T1 minus T2 divided by L1. Okay. And we know uh, what is this? This is Q1. So we can say Q2 equal to 2 times of Q1. Okay, everyone. Therefore, option B 2Q1 will be correct. Clear? Okay. Now the next question is, a uniform metallic rod rotates about its perpendicular bisector with constant angular speed. If it is heated uniformly to raise its temperature slightly, then uh, Given options: option A, its speed of rotation increases; option B, its speed of rotation decreases; option C, its speed of rotation remains same; option D, its speed increases because its moment of inertia increases. Okay, so which one is the correct? Okay, think about it and please try to solve this question, everyone. You will solve the question first. Okay, which one is correct? Yes, please try to solve this question, everyone. So the correct answer will be option B. Okay, its speed of rotation decreases. Let's examine its solution. Generally, materials expand upon heating. Yes or no? This implies that the length of this rod will increase if we heated it. Okay? If the rod's length increases, then its moment of inertia will also increase. Alright? So here the moment of inertia I about a perpendicular bisector increases. Now, since no external torque is acting, it's okay. So its angular momentum will be conserved. Why? Because we know dl upon dt is equal to tau external, and if tau external is 0, meaning torque is not acting. Alright, then angular momentum will be conserved. Therefore, according to the law of conservation of angular momentum, its angular speed omega will decrease, because angular momentum can be written as I cross omega, and if I increases, then omega will decrease. Okay. Now let's move to the next question. There are two different slabs, A and B, of different materials, but with the same thickness are joined as shown in the figure. Okay. Uh, the thermal conductivities of A and B are K1 and K2 respectively. The thermal conductivity of the composite slab will be what? So, what will be the thermal conductivity of the composite slab? Okay, this has been asked. There are four options. Option A, 1 by 2 K1 plus K2. Option B, under root K1 K2. Option C, K1 plus K2. And option D, 2 K1 K2 divided by K1 plus K2. Alright, so which one is correct? Please try to solve this question, everyone, and find out the correct option. Please solve. Yeah, which one is correct? So the correct answer will be option D. Okay. Let's see the solution. Uh, as we know, current is same in a series combination. Okay, series combination of resistors. Similarly, here the heat flow will be the same in this given configuration. All right, meaning this configuration represents a series combination because there is an end-to-end connection. And if we replace this system with an equivalent rod, then the equivalent thermal resistance will be L upon Ka. And we had studied this in thermal resistance section. So since we can write Rc equal to R1 plus R2, here we put the given parameters. So we can say L upon Kc into A is equal to L by 2 upon K1 into A plus L by 2 upon K2 into A. Okay. So solving the formula, you will be get Kc equal to 2 times K1 K2 divided by K1 plus K2. It means uh, option D is correct. All right. Let's move to the next question. The coefficient of thermal conductivity of copper is 9 times that of steel. In the composite cylindrical bar shown in the figure, look at here. This is we have a composite cylindrical bar. What will be the temperature at the junction of the copper and steel? Okay, so this one is the junction and you have to find out the temperature at this point. We need to determine the temperature at the junction of copper and steel. Here the given options, option A 75 degrees Celsius, option B 67 degrees Celsius, option C 25 degrees Celsius, and option D 33 degrees Celsius. So which option is correct? Please try to solve this question, everyone, and find out the correct option. Yes, this is a very simple question. Which one is correct? Let's see the solution. The correct option is option A, 75 degrees Celsius. So as we studied in theory, in series combination, the temperature of the interface is given by T equal to K1 T1 L2 plus K2 T2 L1 divided by K1 L2 plus K2 into L1, and this formula is valid for when lengths are not equal. Okay, so let's assume that the left part is steel and the right part is copper. So it is given that thermal conductivity of copper is 9 times of steel. So let steel has thermal conductivity equal to K, then K copper equal to 9 times of Ks. So we put the given data into the above equation, we get T equal to 9K into 100 into 6 plus K into 0 into 18 divided by 9K plus into 6 plus K into 18. So we have this expression. So just put the values and solve it. You will be get T equal to 5400 Kelvin divided by 72 Kelvin. It means 75 degrees Celsius. Okay everyone. Next question. Three objects colored black, grey and white can withstand hostile conditions at 28 degrees Celsius, 2800 degrees Celsius. These objects are thrown into furnace where each of them attains a temperature of 2000 degrees Celsius. Which object will have the brightest glow? Okay, so will all three have equal brightness? So given options: option A, the white object; the option B, the black object; option C, all glow with equal brightness; and option D, gray object. Which one is correct? Think about it and please try to solve this question, everyone. Which one is correct? A option, B option, C option or D option? Let's see the correct option. So correct option is B, the black object. Here we need to understand that a black body is one which emits all kinds of radiation at a certain temperature and absorbs all radiations falling on it. Okay, it means it has emissivity equal to 1. So if a black body and an identical body are kept at same temperature, then the black body will radiate maximum power. Okay, hence the black body will have the brightest glow. Okay, let's move to the next question. A black body maintained at a certain temperature radiates heat energy at the rate q watt. if its surface is smoothened so as to lower its emissivity by 10%, what will be the increase in its rate of radiation at double the initial temperature? Okay, this means two things are happening simultaneously. Okay, firstly its present emissivity becomes 90%. Secondly, the initial temperature has been doubled. So we need to find the increase in temperature. We need to find the increase in the rate of radiation. Okay, so there is a four options. You have to find out the correct one. Option A, 0.9 into 2 raised to the power 4 minus 1 into q watt. Option B, 0.9 into 2 raised to the power 4 q watt. And option C, 0.9 into 2 whole power 4 q watt. And option D, 0.9 whole power 4 into 2 q watt. So you have to find out the correct one. Which one is correct? Please try to solve this question, everyone. After that, we will provide the solution of this question. Okay. Which one is correct? So the correct option is option A. Okay. We know for a black body, the rate of radiation loss is given by the formula, that is Q equal to sigma into A into T raised to the power 4. So let's assume the initial rate of radiation loss was Q equal to here sigma into A into T raised to the power 4. And after smoothing and doubling, the temperature is equal to rate Q prime. So Q prime equal to 0.9 into sigma into A into 2T whole power 4. So when we solving this, you will be get the Q prime. Okay. So from here, the increase in its rate of radiation will be final rate of radiation minus initial rate of radiation. Okay. That is 0.9 into 2 raised to power 4 minus 1 q watt. This means option A will be correct. Let's move to the next question. We consider the radiation emitted by the human body. Which of the following statement is true? So there is a four statements. A, the radiation is emitted during the summers and absorbed during the winters. B, the radiation emitted lies in the ultraviolet region and hence it not visible. C, the radiation emitted is in the infrared region. And D, the radiation is emitted only during the day. So which one is correct? Please try to solve this question, everyone. After that, we will provide the solution of this question. Okay? Please solve. Which one is correct? A, statement A, B, C or D? Let's see the solution. So the correct option will be option C. Okay. If we talk about a black body, it means it emits all types of radiation at any given temperature. Okay. But if we talk about other bodies, the situation is different. Now, if we talk about the human body, it mostly lies in the infrared region. Okay, so heat radiation emitted by the human body have wavelength of the order of 7.9 into 10 raised to the power minus 7 meter to 10 raised to the power minus 3 meter, which is in the range of infrared region. Hence human body emits radiation in infrared region. Okay, let's proceed to the next question. Parallel rays of light of intensity I equal to 912 watt per meter square are incident on a spherical black body kept in surroundings of temperature 300 Kelvin. Take Stephen's constant sigma equal to 5.7 into 10 raised to the power minus 8 watt per meter square Kelvin raised to the power minus 4 and assume that the energy exchange with surroundings is only through radiation. Okay. The final state temperature of black body is close to what? Which option is correct? A, B, C or D? A is 330 Kelvin, B 660 Kelvin, C 990 Kelvin or D 1550 Kelvin. Which one is correct? Please solve this question, everyone. Which one is correct? So the correct option is A, 330 Kelvin. So to understand this, we need to grasp the concept of steady state. Okay. Steady state here means that the black body's temperature has become constant. Alright. So implying that it is rejecting as much energy as it is absorbing. So in steady state, energy incident per second is equal to energy radiated per second. Okay. So the power absorbed by the spherical black body is given by the product of incident intensity and the cross sectional area of the sphere. It means P absorbed will be I pi r square. Okay. And the power radiated by the spherical black body is given by the Stephen Boltzmann law, which is the difference between the power radiated by the black body at temperature T and the power absorbed from the surroundings at temperature T naught. Okay. So we can write it mathematically. I into pi r square is equal to sigma into t raised to the power 4 minus t naught raised to the power 4 into 4 pi r square. So when we rearrange the formula, you will be get I equal to sigma into t raised to the power 4 minus t naught raised to the power 4 into 4. So just substitute the given values in the above expression, you will be get the value of t, that is t raised to the power 4 equal to 121 into 10 raised to the power 8. After simplifying this, you will be get 330 Kelvin, okay, approximately. So this is just mathematical calculations. When we after simplification, you will be get the temperature. All right, let's move to the next question. A spectral energy distribution of a star is maximum uh, at twice temperature as that of the sun. Okay, so the total energy radiated by the star is what? Given options: option A, twice as that of the sun; option B, same as that of the sun; option C, 16 times as that of the sun; and option D, 1/16th of the sun. So which one is correct? Please try to solve this question, everyone. After that, we will provide the solution of this question. Okay. So the correct option is C. Let's see the solution. So according to Stephens Boltzmann law, intensity of radiation emitted is directly proportional to temperature of the black body. So I equal to sigma into t raised to the power 4. Okay, where sigma is Stephens constant. Given temperature of star is 2 times than that of sun. So T equal to 2 into Ts. So the new intensity I prime equal to 2 in sigma into 2 Ts whole power 4. When we solving this, you will be get 16 into Is. Hence the total energy radiated by is 16 times as that of the sun. So C option is correct. All right. Let's move to the next question. Newton's law of cooling holds good only if the temperature difference between the body and the surrounding is what? Given options: option A, less than 10 degrees Celsius; option B, more than 10 degrees Celsius; option C, less than 100 degrees Celsius; and option D, more than 100 degrees Celsius. So which option is correct? Please try to solve this question, everyone. Yes, which one is correct? Newton's law of cooling holds only for less temperature, okay, or minimum temperature, and that temperature is what? You have to find out that. Okay. So the correct answer will be option A, less than 10 degrees Celsius. All right. Listen, everyone. Uh, First, let's see what Newton's law of cooling is. Okay. So we can say Newton's law of cooling states that rate of cooling of body is directly proportional to temperature difference between the body and the surroundings. So Newton's law of cooling works correctly only when the temperature difference between the body and the surroundings is approximately less than 10 degrees Celsius. If the temperature difference becomes too large, okay, then this law does not work. This is an important point that you should always remember. Therefore, our answer is A. Yes or no? So we can say dt upon dt is directly proportional to theta minus theta naught. So difference theta minus theta naught is should be small, nearly less than 10 degrees Celsius. So we can say A option is correct. Okay. So this is our correct answer. Clear? Any doubt here? Yes or no? Anyone? That's all for the today. Thank you for your attention, students. In next lecture, we will learn oscillations. Okay. Thank you for your attention. Thank you.